Just a second. Yes, I'm live now. Hello, wonderful people of the internet. Welcome back to another episode of Leos Labs. Today, I want to talk about where I've been for the past couple months. I guess it's just been 1 month. So let me go to youtube.com and let me show my channel really quick. 1 second. youtube.com/user/LEIOS. And let me share that screen. Okay, so here's my YouTube channel, right? Look. On the home tab, it's been a long time since I really put any content out. I understand that. I'm with you. I understand it's been like basically 3 years since I put out like a standalone, a good YouTube video. There was something I put out 9 months ago related to the introduction to GPU programming with Julia, which I thought was a pretty good video, but I do understand that, look, some people are just not into watching an hour-and-a-half long discussion about Julia. I get that. But let's talk about the live tab, okay? So, a few months ago, I started making content again, specifically started making live content again. I had a bit of a drought. I kind of didn't want to put out live content of that form, and I decided I didn't want to do it. To be honest, after Trump's inauguration, I kind of realized that there was winning when he won the popular vote. He didn't even win the popular vote. When he won the election, there we go. That's the word I'm looking for. When he won the election, I kind of realized that there was a huge disconnect between researchers and like everyday people. And so I started streaming again, right? And so you see a video here 2 months ago, and then, a couple other videos scattered around 2 months where I talked about a whole bunch of different things. I talked about poetry analysis with AI. I talked about should you do a PhD. I talked about a whole bunch of different things here. But the majority of my content is still not available publicly. And I totally understand that. It's a lot of live streams that just are not available for people to watch for various reasons. There's some stuff on my second channel, Leos Labs Live, which I guess I can show here, Labs Live. But for the most part, if you're looking for content from me, it's kind of difficult to find the content you might be looking for. So here is that channel right there. So if you go to playlist, you can find some content there. I'll go ahead and post the link here, as well as here. Now, the reason I bring this up is because basically after I started streaming again on my main channel, I started to try to make live streaming a more regular occurrence on my, just in terms of my daily life, right? I started realizing that by doing what every other researcher does and kind of like hiding the research that I'm doing or like, doing it in private, I was not engaging my audience. And by not engaging my audience in the research that I was doing, this would ultimately lead to, again, a very large disconnect between researchers and everyday people. And I thought it's very important to start tackling that. Because like I said in yesterday's stream, to me, the number one issue that I personally can tackle is anti-intellectualism. It's this idea that scientists, that researchers, that smart people don't know what they're talking about, right? Like this is the type of stuff that I personally can tackle, and the way I can tackle that is by showing as much research as I can available publicly. Now, the problem with that is something that I've said time and time again. It is very difficult to do live stream content that is technical, right? It's very hard to do research live. It's very hard to do writing live. There's so many things that are hard to do live, just because it doesn't form compelling live content. You know what I mean? Like if you're watching someone write a book, I guess that's fine, but like, how many people out there actually want to watch someone write a book? It's not a very large number of people. You know what I mean? And so I constantly second guess myself and constantly think to myself that maybe I should not be making this content, right? Now, with all that said, for the past few months, really, I mean, basically for the past month since my last live stream, I've been doing a lot of different stuff, and I want to talk about those things that I have been doing, and then briefly mention yesterday's stream before moving on. I don't want to talk too much about yesterday's stream. I think it was itself a concise narrative that is exactly what I wanted to say. There may have been a few tangents that I should not have said, and honestly, we did not go far enough in certain discussion points, but to be honest, I don't really want to talk about politics very much on this stream, and I just did it that one time because I felt like it was important to get my perspective out there and known. From there, I don't really have any intention to talk about it unless it comes up in conversation. So let's talk about what I've been up to. So Zernal PP. Okay, first of all, let's talk about the little things, right? So you guys know that I've been working at MIT, right? The Massachusetts Institute of Technology. So I have mostly wrapped up all the stuff I'm doing for MIT. There's some small little things that I have left to do, but at this point in time, it's mostly all wrapped up. That is to say, I still have a pull request that I have to merge for the molecular dynamics engine that I'm working on called Molly. I have a paper that we're just now finishing up for MIT, but for the most part, that's all done. So again, what does this mean? It means one, Molly, the molecular dynamics engine, is now heterogeneous. It, in principle, can work on any architecture, which is great. I got another paper out for, let's say, how do I put this even? I have a paper that is going to be coming out on tri-diagonal methods, so TRMM and TRSM, in which we get actually blast level performance with our kernel abstractions API, which is a package that I've helped develop. I would not say I am a primary developer, but I have my name in there somewhere, related to basically the ability to write a single kernel that can execute on various hardware, right? So this is kind of the stuff for MIT that I've been finishing up, just kernel abstractions work, all this kind of stuff, GPU work, and that kind of stuff. I will say I have another paper coming out as well that was written with close collaboration of several people that is related to spin orbit coupling for physical a simulation of spin orbit coupling. I'm like middle author there, if anything, like the least important author, but I just want to say that it was something else that happened in the past week or month or so. So this year already, I have 2 papers that are coming out, and I've basically finished up my MIT job. And so yes, I've not been putting out too much live streaming content. I haven't been putting out that much in the past month. On the other hand, I think it's important to acknowledge that I'm kind of ramping up the Laos Labs work. And in particular, what I'm focusing on right now is the GPU handbook. I'm going to go ahead and show it to you on laoslabs.com. Slash, I guess it's just GPU handbook. Here it is. By the way, hey Hanif, how are you? Hey Hanif, how are you? My goodness, I can't speak. So right now, there's not much here, right? I'm going to go ahead and post a link in both chats. So here, and then also here. But I'm just now finishing up chapter 2. I have about 10,000 words written in chapter 2, if you combine chapter 1 and chapter 2. So what do we have here? We have the introduction, talking about what a GPU is, why we should care about graphics programming, talking about the different architectures that are available, and also talking about the different languages to target those architectures. And we talk about the fragmentation of GPU interfaces, all this kind of stuff. So this is what the intro is basically just talking about the current state of GPU programming. The next chapter, the one I'm working on right now and I'm finishing right now, is on different abstractions that you can use to use the GPU as fast as you can. To use the GPU for fast computation, right? And I think, mainly done with that chapter. And so I thought today we could just sit down, we could review the book as it is written right now, talk about different things that I want to do in the future with it, and future directions, all this kind of stuff. So my plan for today is to revise all the stuff I've written, both for chapter 1, doing the introduction right here, and also to move on to chapter 2, which is the one that I have not yet created or finished yet, but it's basically done. You know what I mean? So my hope is to read through everything and to get as much done as I can. I don't know how much I can do in the next 2 hours, but I'm going to try and see how far we can get. Now, keep in mind, this whole conversation, everything that we're talking about here, is kind of interrelated, right? I have said time and time again, it's very difficult to do writing content on stream. It's very difficult to do research content on stream. And though I do love reading papers and pulling them up on stream and talking about them and all this kind of stuff, I also acknowledge that this type of content is very difficult to do well, and I'm not entirely convinced that I'm someone who is doing it well. It takes training, it takes time, and so what I want to hear from you guys, both in the chat and also in the comment section of this YouTube video, is if I'm hitting the mark. You know what I mean? Like, is this type of content that you want to see in the future? Is it not? That kind of stuff. Speaking of content that people might want to see in the future, I do need to acknowledge the stream that happened yesterday. So yesterday, I made a video talking, I believe somewhat briefly, about some of the most recent actions that Trump has taken as President of the United States of America. Now, for the record, I don't intend to make more political content. Just for the record, not my intention. Now, the reason I don't want to make more political content is because I think I said everything that I can possibly say about the intersection between research and politics as part of other live streams, and also as a part of that live stream. I already said everything I think I can say, which is to say fundamental research is important. We should still fund it. And 2, there's a whole bunch of really interesting research areas that we are ignoring now that it'd be nice if we didn't ignore. That's it. That's what I said. I don't even think it's an incredibly political topic. I think I said it in an incredibly, like, tepid way, if anything. Like, it's just like, I don't think I actually, said anything that was like incorrect or even, outside of my wheelhouse. But I will say that because I was, in a sense, directly criticizing some of the things that Trump said, there was a lot of, I'm not going to say negative feedback, but I will say a lot of people who were not going to listen to what I had to say simply because I was critical of Trump. And I suppose I can understand their perspective. In a sense, because if their entire social circles are related to maintaining their like Republican image, and I'm here bucking that trend. I do understand why people are upset about that, and I get that. I personally was hoping that they would at least listen to what I had to say. But I learned a lot in the comment section. A lot, actually. I learned there's this thing that's called the Trump, what is it? Trump DS? Trump, what is this called? It's even got a Wikipedia article, Trump derangement syndrome, right? I'd never heard of this term before until the comment section when they said that it was a 3-hour rant about my Trump derangement syndrome. I don't even know what this is, to be honest. So I looked at it. It's interesting. It's a pejorative term usually for criticism or negative reactions to President Donald Trump that are perceived to be irrational and have little regard towards Trump's actual policy positions or actions undertaken by his administration. Now, to be clear, I do not believe that the video in which I put out was at all irrational. I believe I said things that were very much in good faith, or rather were very much as a part of like a natural consequence of what we know from his previous administration, and also what he has currently done as president, right? So I don't think I said anything that was controversial. The most controversial bit was probably the relatively long discussion about trans I don't know, healthcare, but again, to me, that's healthcare. That's not political. The way I see it, if you think that trans discussions are political, then I don't know what to tell you. They shouldn't be. It's a healthcare thing. You know what I mean? So that might be a disconnect there, and I do understand how that could be a disconnect. But for the most part, my takes were we should fund fundamental research, and I don't know, maybe trans research is interesting because I find it interesting. It is really cool when you think about it. Like, these people are bucking a trend. Like, they're literally using like the latest biomedical available hormonal treatments. I don't know what I'm trying to say here, but it's quite cool, right? Like, these people are like literally transforming from, male to female or the other way around. That's cool. I mean, like, I don't know how to tell you. Like, if you like Transformers, like, this is the same thing but human. It's pretty cool. I think it's neat. So long story short, I will acknowledge that in the last video, I may have said some things that I don't necessarily stand by, but I did keep that video up and I did keep the stream up, both in the, like, both for transparency's sake and also because I just feel like, again, I didn't say anything super controversial. I think I said everything that I meant to say, albeit with maybe, I may have missed a few points here and there, but I think it was pretty clear. What's this? Yeah, I never heard of this before either. The comment section was, there were a couple people who said I had TDS. I did not know what that meant. Because there was a very long conversation about trans, I immediately thought that it was like some trans DS. I didn't know what it meant. So I had to Google it. I had to figure it out. I don't know what this is. If you are someone who regularly uses this phrase, I can only imagine you're in some social circles that I'm not a part of, in which case I'm actually very happy that you're here. Because if you are here and a part of different social circles, that's how you have conversations that lead to the betterment of both parties. You know what I mean? So, let's keep going. I hate the term DDS. It's so overused and shut down legitimate criticism. That one commenter is, in my opinion, genuinely insane. It's getting overused now. I'd never heard of it before this term, before this. Also, I guess just do what you like, no pressure. The thing is, the stuff that I like is like reading papers, and like nobody likes watching videos of people reading papers. Their principles are: one, contrarian. You tell them X and they go, no, X. That's true. E.g. TikTok ban. Yeah, I don't know what's going on with the TikTok ban. I really thought Trump's whole thing was that he wanted TikTok banned, and now he seems to be the one that wants it not banned. I don't know. I don't know what's going on there. Let's see. If it's not white cis male, it's political. There are two genders, man and political. That actually might be what some people believe. But again, this is not a political stream, and I don't want to go any further with a political discussion. I just wanted to acknowledge that it happened. To say, I don't think I said anything wrong in that video, and I do stand by everything that I say. If you believe something different than something I said in that video and want to have a discussion on that, I'm actually more than willing to have that discussion later. In fact, if you can send me a bunch of research papers proving your points, I will read those research papers and I will have a legitimate discussion about those papers, because this is a research stream. I love talking about research. Reading papers, that's my jam. I love that type of stuff. So give me legitimate research papers discussing the topics at hand in order to refute any points that I made, and I'm more than willing to talk about that, right? Like, that is totally in my wheelhouse. And speaking of it, there was one other thing, like a comment that did kind of grind me a little bit. It was the only one that grinded me. The Trump derangement syndrome stuff I didn't find particularly, like, fine, whatever. These are people I can't really talk to because they're so far outside of my social bubble that there's no way I can have a legitimate conversation with these people. But there was some people who said that that particular video was very far outside of what they expected from my stream. And to which case I was like, what did you expect? Like, this stream, fundamentally, I mean, that stream was a 3-hour, like, rant that was vaguely related to the topic at hand. It was basically discussing research topics around that area again for 3 hours. That to me is like the most stereotypical Laos Labs content that I could have possibly produced. Outside of maybe the fact that I mentioned Trump in a negative light in like the first 15 minutes. But after that, honestly, we didn't even talk about Trump. We were talking mainly about research and research ethics. And we talked about a research issue being trans healthcare and how like there is some misrepresentation and we have to sift through that. There was a lot, the whole debate was about research integrity more than anything else. Speaking of which, we have a couple things now on the Discord that I do want to shout out. The first of which is we have a project forum for research topics. So if you're somebody who wants me to talk about a particular research topic, go here, create a post, talk about the thing that I want to talk about, give me some papers to dig into, or else maybe try to find other people in the area who could work on the project together. I would like to find a way to get more people involved with like the concept or the movement of research outside of academia or even within academia if you happen to be a PhD student. The main point here is I would like to get more people doing research, and having a small forum on the Discord is like the least I can do to make that possible. The other thing that I wanted to say is we actually had some discussion about some of the numbers that I put down or had written on the updates channel, and it's actually more bleak than the numbers I had put out in terms of like detransition rates and stuff like that. You can read that if you want. But the big discussion that happened was about reproducibility and how there is a reproducibility crisis in academia. I think everybody knows about the reproducibility crisis. In the case you don't, it is the inability for certain research papers to be reproduced. Now, my take on the reproducibility crisis is that, yes, it is true that some papers cannot be reproduced, but you have to remember that no papers occur in a vacuum, right? If the paper is well cited, that is, in a sense, reproduced in the papers that are citing the paper, because in order to build off of a paper, you have to first reproduce a result of that paper to move beyond it, right? And so in a lot of cases, just by having a larger number of citations, you can generally trust that that paper could be reproducible, or at least is incredibly important and influential in the field, right? That's number one. Number two, I feel like the reproducibility crisis is an attempt at certain people to discredit the nature of certain research fields in such a way that I do not agree with. Yes, it is true that probably sociology papers and psychology papers are much harder to reproduce than, let's say, computational physics papers, right? Because computational physics papers, you can generally just run again with, the same code or even different code that you've written yourself, and you should get similar results. That's not true for sociology studies and stuff like that. And so there was some discussion about how we could start targeting the reproducibility crisis and what we could do about it. And like, I am all for the idea of creating some sort of journal or something like that that will publish basically nothing unless it is reproduced by that lab in the journal. I've thought about this, and it's something that, like, if I had an infinite amount of money, I would be willing to do this. If this is something that people want to pursue, I could imagine a series going forward where we take papers and we just reproduce them. Not necessarily in the, like, we won't like republish the results or something, but if there's a paper that seems suspicious and you think is not correct, I've long thought it might be a good idea to look at the papers, to study them, and to actually go through and try to reproduce the paper as they're written down. And I thought it could be a good series to go through different research topics and stuff like that. So if this sounds interesting to you, like you have some papers in mind that you think are a little bit sus, but don't know how to actually check the methodology, and my methodology is like the stuff I can do in terms of GPU computing and stuff, it lends itself to testing this thing. It might be something that we could consider in the future. So in the paper pile, throw those papers down. And then also, if you have some specific research topics you want me to look at, put them here in the topic board. That's what I wanted to say. A lot of people like watching people like Prime Again reading articles on stream, including me. I totally love to see the same for research papers. Yeah, I'm a big fan of this type of stuff. What if the citations are showing it as bad as a non-reproducible example? That could be fair. Like in that case, yeah, citations are kind of a bunk metric, but it's still an okay kind of back of the envelope calculation to make sure things are working. Let's see. There is a molecular biologist that talks about COVID, and many commenters say, so you hate Trump. Yeah, this is... Again, I don't want this to be a political stream. I tried to get all my political discussions out in the last stream. But what I will say is the following. The fact is that when people say clear science, people are for some reason assuming that science is political. And that is a big problem, right? And that fundamentally is why I'm streaming to some extent, right? Like, it sucks that I'm sitting here saying I'm a researcher and people are just like, oh, so you're, a liberal propagandist or something. I'm like, no, I literally sit and do GPU computing all day. Like, I don't care about any of these issues. The only thing I care about is that, like, we continue funding research because that's how you push the economy forward. That's it. That's my stance. I feel like it's an incredibly lukewarm stance. Like, I don't care if Republicans are suddenly funding research more than Democrats. That's fine. I mean, like, if I don't, there are a lot of social issues I have wrong with the Republican Party, but if they are suddenly on board with 100% of different scientific topics, like if they are pushing areas that I feel should be pushed, I mean, that is incredibly beneficial for everyone, right? Like, it doesn't matter. Like, I'm not playing sides here, right? Like, if Trump does something good, fine, that's great. I'm happy he did something good, and that's a win for everybody if he does something good. You know what I mean? Like, this isn't like, we don't need to do party politics here. You know, if Trump all of a sudden realizes that, like, I don't know, it's good to invest in certain research areas that I also feel are great to invest in, like, you know, alternative energies or climate related things, I'd be like, great, this is a win for everybody, right? There's no reason to be mad at that. You know what I mean? So anyway, long story short, it is a little bit annoying that when we do say stuff that does have clear scientific basis behind it, or at least is what we currently understand about the world around us, when people assume that that's a political take just because you're stating facts, it is a problem, right? And that's an issue. If the paper is bad, eventually many papers citing that will encounter contradiction. Thus, the validity of the original paper is questioned. Right. So this is, I think, the major way that we start, like, tackling reproducibility in scientific papers as it is right now, in saying that, like, people will eventually find the issues if the paper is novel and useful enough, right? Suggesting research topics, I want you to have a look at algebraic Julia. I've only heard specialists talk about it, so I'd be interested in your perspective. I don't even know algebraic Julia. I'll look at it in just a second. And if it's actually fraud, then it's not impossible to prove. Then it's not impossible to prove data fraud with many, many statistical tests. 1 second, I got a cough. I'm a little bit sick. I'm so sorry. I'm getting a little sick. I don't exactly know why, but anyway, let's take a look at algebraic Julia before moving forward. I will say the following. Even though I'm a member of the Julia Lab and I do a lot of Julia stuff, I consider myself to be first and foremost a researcher. And by that I mean that if the research I'm doing cannot be easily done in Julia, I will not do the research. I will do the research even if I don't use Julia for that research. You know what I'm saying? Like, I'm a big fan of Julia as a language, and I'm obviously one of the, like, a relatively big developer in the Julia GPU ecosystem, considering the number of users and stuff like that. But if I can't use Julia for a topic, I will still continue to do the research, even if I happen to not use Julia for that research, is what I'm trying to say. So one of the big research pushes that I'm doing right now, I actually found after a long time working on it that I just can't use Julia for it. I spent years of my life devoted to getting this thing to work in Julia, and I could not. So I've switched the project over to using OpenCL, and it's just been so nice. I'm such a big fan of OpenCL. Well, I'm not going to sit here and say that Julia is the absolute best language for everything, but I will say that I'm particularly tied to the language, and I find it nice to use for a lot of different things. So let's take a look at what this is. Algebraic Julia aims to create novel approaches to scientific computing based on applied category theory. Let me see who's putting this in here. These are all groups I don't know. I don't know anything about these people. I don't even know. I don't know anything about this. Bringing composability to technical computing. Let's take a look at the mission. Algebraic Julia. So a framework for applied category theory in Julia language. Build Petri net agent-based models compositionally. Build SQL categorically. What? Build dynamical systems compositionally. What do they mean compositionally? Simplicial sets and other combinatorial models of geometric spaces. Well, I am I am very much I don't know what this is at all. Hey Amaris, how are you? By the way, OpenCL or OpenGL? I'm using OpenCL. Unfortunately, man, my throat. Sorry about that. OpenCL or OpenGL? Unfortunately, OpenCL is not that well supported in my experience. Yeah, so OpenCL, as many people like to rag on it, is still the most supported compute language available today. I can make that claim, and it is a true statement, right? You could argue OpenGL and Vulkan have greater usability, as in more people are able to use them on more hardware, and I think that is a true statement. But in terms of performance portability for compute languages, OpenCL is still the best one. It still runs on Mac. It still runs on basically any CPU. In fact, with Pockle, which is the portable OpenCL language, you can run it on basically anything. Now, Pockle works in a super weird way in that it basically takes a SPIR-V output from OpenCL and then puts it back into LLVM. So for Julia, what you do is you basically compile out LLVM and you instead spit out SPIR-V, and then you put that through Pockle to then get LLVM back. So it's like this really weird compilation cycle in order to get parallelism through your GPU framework for parallel CPU execution from like kernel abstractions or something like that. But it is what it is, you know? In fact, when it comes to Julia, I did want to say something that I've been recently realizing. So a lot of people say that the speed and performance from Julia comes from the fact that we compile down to LLVM. And this is a true statement. But I think it's more important to think of Julia as like a Mojo competitor, in that like when it comes to heterogeneous computing, it's, how do I put this? We actually output an LLVM-like language, not LLVM itself. So we output like NVPTX or something like that. Or in the case of Pockle, we're actually outputting SPIR-V. Or with SPIR-V.jl, we're actually outputting SPIR-V itself, you know? And so with this in mind, you can think of it more as like we are doing the MLIR stage of Mojo at the Julia level is essentially what we're doing. And I think this is not clear to a lot of people writing Julia, like what the differentiation is between Mojo and LLVM. And I think Mojo and Julia. I think the big difference is that for Mojo, the code compiles down to MLIR and then compiles down to its LLVM-like dialects, you know? Whereas with Julia, the code has an LLVM pipeline, but could also be using that LLVM pipeline to output like similar lower level representations. So the reason I'm bringing this up is because I think there's a lot of people who like they compare Mojo to Julia, and I think it is a very fair comparison to make because they do both kind of do the same thing. And I have always been kind of curious as to what the Mojo people are trying to do. I think in the end, like people just want to create their own language, and because they want to create their own language, they're willing to they'll just do whatever they want to create that language. Like the other day, I was thinking about doing a SPIR-V compilation pipeline, just because, I don't know, I just wanted to write a language that compiled down to SPIR-V as fast as possible because having dynamic recompilation is super cool. And I feel like too many people are focused on moving a lot of the power of programming to the compiler, and I feel like that's not a good idea. I feel like what we should be doing is minimizing the size of the compiler, so that we can, or minimizing the runtime footprint of the compiler so we can do dynamic recompilation, because I feel like metaprogramming is such an important thing for programmers nowadays that like I really, really do wish we had faster compilation pipelines. And of course, as someone coming from Julia, that will sometimes have like a minute or two compilation while waiting for something to run. And when it runs, it's like, you know, a millisecond or something to run. You know what I mean? Like, so Julia might be on the far end here where it has like incredibly long compilation pipelines for incredibly short runtime, which is kind of the opposite of what I want. I don't mind having a slightly longer runtime if it means that your compilation time is smaller, which to me says I should be using C. Anyway, I'm rambling about languages, and you should never get me rambling about languages because eventually MATLAB will come up and then the stream is over. I'm sick 3 hours later, but whatever. Yeah, I'm also sick. I hate to say it, but man, my nose is a bit sniffly, and there's only so much I can, like, you can probably hear it a little bit in my voice. Certainly no Leia streams coming up if that's what you're looking for, so. Okay, so that's what I've been up to. I got a couple of papers out. I finished up the MIT work, and I'm now working on a few different projects. So one is the GPU handbook. Another one, I'm actually really excited for this one, is a fiction book. This should be coming out after the GPU handbook is done. I'm kind of writing it together at the same time as the GPU handbook. It's actually a novel in verse as an exploration of imposter syndrome, and it's really cool. I'm a big fan of like the magic system created for it, like the world itself. Basically, it's like if Edgar Allan Poe wrote a Japanese light novel is what you can think of it as. It's really fun. I'm a big fan of it, and the hope is that once I get these books done, I can then finish up my engine, which is Quibble, and I can use the animation engine to create an animation for the fiction book. I'm hoping, hear me out, I'm hoping for a live stream, basically VTube model from my engine that uses a fundamentally different compositional pipeline than basically anything else on the market. So if I could do like a real-time kind of like VTube type of thing, I mean, that would be a really, really good paper to put out into SIGGRAPH or something like that. So Quibble right now, it used to be called Fable, which you guys might not also know, it is a rendering engine. Yes, that's what it is. In particular, what it does is it renders based off of iterated function systems and chaos games and stuff like this. So essentially, it is a fractal renderer, but it uses the iterated function system approach to do general purpose rendering, right? And if you can do general purpose rendering, so I found that the runtime for this is like you can get like 5,000 frames per second if you have the right everything precompiled beforehand. And so in general, it can get to real time results, right? And what it does is it kind of gets rid of the mesh geometry entirely, and it instead says that your mesh is an iterated function system. And if your mesh is an iterated function system, then you can just directly type that up. It gives you the ability to do smear frames and like a whole bunch of other crazy operations that you would not ordinarily be able to do. There's a lot of really, really cool things you can do if your approach is iterated function system based instead of mesh based. And it could lead to a lot of really good results in the future. I'm really looking forward to where it goes. It's quite quick. I think there's a lot of really good reasons to do it. And I recently found out that you can actually take the algorithm that I've implemented and probably create a quantum version that uses superposition of qubits in a way that you would not ordinarily do on like a classical GPU device. And that formulation of the quantum version of this algorithm could be something that we get a type of quantum advantage for graphics, which would be really cool. Right now we can't do that because, I mean, I am loosely working with some quantum people here, but unfortunately, like we only have like 5 qubit systems, and specifically we need an analog quantum computer to do this type of computation. But the way I see it is it's not quite there yet, but if we could get a few more bits on an analog quantum computer, we could start to make animations with it, and you could see a quantum advantage with graphics, and that'd be really cool. That's a really nice paper, probably even, I mean, not Nature, but probably PRL. I mean, like, that's pretty good. Let's see, what do we have here? What's Quibble? Okay, that'd be really interesting. Nice. Hello. I've been at the Rust conference last month. One speaker said they didn't manage to accelerate latency of NumPy plus SciPy code using Julia. So they settled for Rust instead. Not trying to throw a rock at Julia. This is influenced by survivorship bias, but that's what I heard. Repeat that. One speaker said they didn't manage to accelerate latency. What's latency in this case? Of NumPy plus SciPy code using Julia. What does that mean? What's latency here? Like, are you talking about like they were not able to get faster performance than NumPy and SciPy? I'm not entirely sure. Or are they specifically talking about accelerators, like for GPU? Because my experience with Rust GPU is very, very... It's not there yet. At least in my experience, the Rust GPU ecosystem is not there yet. And in 2025, when literally the only thing you care about, or only thing I care about in a programming language, is the ability to metaprogram GPU kernels, Rust just does not have the ability to do what I need to do most of the computation I want. That's where it's at. Faster programming. Oh, so you mean, so by program completion, you mean compilation plus runtime? Or do you mean just runtime? If it's actually fraud, let's see. I have this image as wallpaper in all my devices. It's so good. Wait, what are we talking about? What is this? Looks similar? Yeah, back when I was using DWN Arch Linux. Okay, this seems slightly unrelated, but I'm glad there's a conversation. So runtime, that's very interesting. So you're telling me the runtime for NumPy and SciPy was faster than Julia. That's very interesting, and we should raise an issue about that, because that shouldn't happen. The runtime for Julia is, so far as I've seen, basically the same speed as Rust, and C and all the other LLVM-like languages. It's within a factor of 2 at the very least. Now, admittedly, is within a factor of 2 fast enough for some computation? Maybe not. Maybe there's some situations where you need faster than that, but at least for CPU computation, which is what I'm assuming we're doing here, you should be getting comparable results to Rust. You may have already mentioned it, but your actual use case workload for your GPU work is rendering type stuff. So I do a whole bunch of different things. So like, for example, my PhD, I did pseudo-spectral methods, pseudo-spectral methods. So that's FFT and stuff. I've done a lot of molecular dynamics, so MD. I've done discontinuous Galerkin, so DG. I've done, which are finite element models, say FEM. I do a lot of rendering, so we'll say splatting here. Basically, there's nothing you can throw at me. I'm not going to say this. There are a few problems you can throw at me that I have not already implemented on the GPU for some reason. So that's... I do most things on the GPU, which is why I feel comfortable writing this GPU handbook, because I know that I've done a lot of different simulations on the GPU for the past 10 years, and I have a lot of experience here in writing and doing this type of thing. So it's okay to be off topic. I really appreciate these types of conversations that are off topic. Time it took to solve a problem on one core, at least CPU. Yeah, it's super interesting that you were not getting good enough performance in Julia, and not necessarily that you get better performance in Rust, but the Julia performance is not good enough. Is something that should be brought up to the Julia team, and we should talk about it as to why that timing is not as good as you would like it to be. Now, if the person was arguing that compilation plus runtime is slower in Julia, I would maybe believe that, because Julia compilation is one of the more complicated compilation processes that I know about, and it is oftentimes a lot longer than other languages. I imagine Rust compilation is comparably faster than Julia compilation, although as of Julia 1.11, 1.11, the compilation speed has gotten so fast that people say it's comparable to Rust now. Even so, if they're talking about like an older version of Julia, like Julia 1.6 or something like this, probably compilation is quite slow, and you can imagine that the time to completion is quite long. Rust compilation is slow too. That's true. People have been saying that Rust compilation is slow, which is why we're comparable to Rust. But in terms of C compilation, man, C compilation is so fast, you know? I will have listened to your rant yesterday when I'm on my way in the train later. Funny how people got triggered and really mad so quick. Curious on your point of view. So for the record, just to talk, I don't want to talk too much about yesterday's stream. I will say that I'm obviously probably not understanding the reason why they were so angry, as well as I should, right? Because I'm coming from the perspective of someone who's not at all upset about what's happening, and trying to find a way. I'm upset. I am upset. But I'm trying to find a way forward, as opposed to just sitting and being upset about random things. So I'm trying to make objective claims as I can about the state of politics in the US and how it pertains to researchers. That was what I was trying to do. As everyone knows, the stream gets really off topic, and it is entirely possible that I said or did things that were potentially out of line. And look, obviously that happens all the time. And as such, it could make people upset. I get that. Although compared to C++, it's fast. Really, C++ compilation is slower than Rust compilation. That's something I didn't know. I think people handled it quite well in the stream. Was it backlash afterwards? So in the stream, we had a couple people who were very upset about my depiction of trans people, saying, which is fine. I do understand that I lingered on that a little bit too long. But after stream, there was a couple very angry people. Of course, like I'm talking about one or two people, right? Not like the majority of people. I think the majority of people understood where I was coming from at the very least, even if they didn't appreciate or agree with my opinions. But I will say that, yeah, there were some people who were very upset at me. Must write some really bad C++ code to get as bad compilation speed as Rust, I would say. Yeah, this is my question as well. Like, how could you... Admittedly, if you're doing a lot of C++ metaprogramming stuff, I could imagine the compiler having to do a lot more, and that could lead to the slower compilation speeds. But, yeah, it seems like you'd have to do a lot to get C++ to be as slow as Rust. Upset people should raise their concerns so it could be heard, but it shouldn't be about being upset. Right. So my opinion is, if you disliked anything that I said in the video, that's fine. They were my formed opinions after maybe a short amount of time reading papers or a long amount of time reading papers. But ultimately, the stuff I tried to say was stuff that I feel I had an adequate standing on, and I could say after at least some research, right? If people disagree with me, that's also fine. But I would love to hear people like actually provide like legitimate research as to why that is the case. Now, I will say the following. There was someone who did bring up legitimate research that I did not read on stream, and I should have read it, right? If I was being as objective as possible, I should have read it. And at the time, I was recognizing that this stream was not about trans issues, and we just spent like an hour talking about it, and I wanted to move on. But if I was being as thorough as I could have been, I should have looked at it in more detail. That is a social faux pas, at the very least, on my part, and I need to do better about this type of stuff and acknowledge that, look, there's some stuff that I don't know, and it'd be great if people could send papers to like the paper pile or something on Discord so we could look at it in more specifically later. That's what I said. It's an divisive topic, and part of their anger may be because they haven't really thought things through. I would think that the additional discussion would help them in the long run. We already spent a ton of time at that point, and it's a big request to read a paper on stream anyway. Yeah, especially when there were other things I wanted to talk about that I didn't get to. C++ also has Turing-complete metaprogramming, which is significantly bogs it down. Yeah, okay, so I have a question. For people who write C++ code, so when I used to write C++ code, it was pretty much C with, like, vectors. Like, I never really used, like, the real plus-plus-y nature of C++. You know what I mean? Origami K, are you a first-time chatter? Well, I've certainly talked to you before, but hey, how are you doing? Long story short, when it comes to C++ and it comes to that language, I did not use it for anything but C. plus vectors. I'm wondering, people who use C++, do you regularly use the metaprogramming like capabilities in C++, or is that kind of something you guys don't touch? For me, I never touched it, you know? I use it mostly in C as well. Yeah. I didn't realize we only spoke on Discord. Also, guys, I do apologize. I'm sick. My voice is quite, like, clicky, and I wish it wasn't that way, but sometimes you can't get around it. Okay, so let's go ahead and start going through the GPU book, one step at a time. And then it's like C compilation times plus 1 or 2 seconds. C compilation times plus 1 or 2 seconds. Yeah, that's not bad, right? But 1 or 2 seconds compilation time can be annoying if you have to keep compiling, right? So that's one of the core problems with Julia, in that, like, when you do the compilation for Julia, right, you basically have to do it every time you open up the REPL, which means that you have to do that compilation a lot, especially if you're like redefining structs and stuff like that. And so it can be very annoying. And so no matter how fast we get that compilation speed, like one of the projects I've worked on, there is basically no reality where the Julia compilation process will be as fast as I need it to be. The OpenCL compilation time was like something like 1,000 times faster than the Julia compilation time, and that sucks. You know, we should at least be somehow comparable, like within an order of magnitude of C compilation, which is what I assumed we were. But there's a kind of like myth within the Julia ecosystem that nobody cares about compilation time. Like they say that at the end of the day, people care about fast run times, which could be true, but I don't. I personally disagree with that. I think that if people are developing code in Julia, then you're very used to sitting and waiting for things to compile to a significant extent, and that compilation time is sometimes so like detrimental. It's so harmful to the overall scale of the project because you're wasting so much development time just sitting and waiting for something to compile, that it might have even been better to just write everything in C to begin with. You know what I mean? Like I don't agree with the myth that people only care about runtime. I think you need to bundle up runtime and compile time together for dynamic languages like Julia. However, when in terms of like comparing its speed to C speed, nobody compares like C compilation speed plus C runtime. You know what I mean? So like if you're comparing it to like a fully compiled language, you should probably just run the compiled part, against the compiled part. I don't know. It's a weird thing, But I guess Arduino has suboptimal build system or whatever. Build systems and linker makes it a bigger difference as well in C and C++. That's true. At first, I loved to be able to adapt types and functions to multiple types. For example, vec3t. But the more I got used to it, the less it actually made sense and had more overhead in writing and debugging. Yeah, I think this is kind of how I felt as well when I tried it before. And then I just stopped using the metaprogramming kind of altogether, and I switched to Julia. That's what I've done. I ditched it later on, and it was like C++ metaprogramming. Right. This is kind of my experience as well, but I think over time, like if I were to look at it now, I might be more like, I might like it more, Incremental Rust is what you experience the majority of the time, and in my opinion, it's fast enough compared to C. Why not look into Clang REPL if you like C++? I don't know what Clang REPL is. Oh, I see. It's like a REPL that runs through Clang. That's actually quite nice. I might look into that. Clang REPL. Yeah, that'd be nice. Is this part of the LLVM project? Hey, that's pretty cool. Linker is also a bottleneck for Rust. C++ template metaprogramming is Doom. As in, it is the game Doom, or is it makes you feel Doom? You know what I mean? Ooh, today's stream, I'm not going to stream for too much. I'm going to get through a bit of the book, and then I think we're going to have to take a break. My voice is, my throat is starting to feel a bit rough. Okay, so let's go ahead and start getting this book done. C++ template programming is not very good. I think it's just when you compare it to other dynamic languages, I guess the metaprogramming makes C++ a dynamic language. I actually don't know what term I'm looking for there. But when you compare it to things like Julia and Python, it's like, well, very clearly, you can do more, you have more flexibility with the type systems there than you do in C. I've been doing OCaml exercises, and I like it more than Haskell. That's good. I know a lot of people have tried OCaml, and they like it a lot. Fast enough, I meant equal to C. It's super bad. Oh, the metaprogramming. I think criticism of certain areas of study tends to be met with vitriol, which then was reflected back against on you. Maybe I'll look at Jess Signal and of Blocked and Reported podcast. What are we referring to in this case? So I think criticism of certain areas of study tends to be met with vitriol, which was then reflected back again on you. So criticism of... Wait, could you be more specific? Transit climate? Yeah, I don't think I even really mentioned climate. I just said that, look, this sucks that the rest of the world is going into alternative energy and we're not. Like, it'd be nice if we could stay on top there. That'd be great. And then, let's see. The trans stuff is also like, I don't even really think I said anything outside of, like, I don't know. I don't remember saying anything that was particularly controversial there. Maybe I did. I did. I brought up like religion as an argument because that's what most people say. Like, I should not have brought up the Bible. I should not have brought that up at all. I should have just said, look, I'm a scientist. I don't care about this. But I acknowledge that most people who are against trans people probably don't care about science. So they probably only care about religion, in which case it's like, well, even religiously, like, it doesn't make sense if you're going. Anyway, I shouldn't have done that. Shouldn't have done that. I learned my lesson. Is your book about GPU or GPU programming in Julia? So I would say that it is about GPU programming in general, but I'm using Julia because Julia is technically the best GPU ecosystem that is available right now. Also, it is the only one that provides heterogeneous computation that is not deprecated on all ecosystems, right? So you could write this kernel and it will run on your CPU, it'll run on your GPU, it'll run on Mac, Metal, Apple Silicon, it will run on Intel GPUs, it will run on everything, right? So if you write this code, it's going to work everywhere. You don't have to think about it. When the world goes medieval age, logic and reason are the light that shines into the Renaissance. Yeah, maybe, yeah. The way I see it is it's important to have conversations. It's always important to have conversations. Conversations that are not angry and that will lead to, how do I put this? That will lead to at least greater reasoning on both sides. That's what I want. Maybe not a mutual understanding of both sides, but at least reasoning, right? I mean, trans people's existence is controversial somehow. This is what I don't understand. I don't understand what the controversy is like. Yeah, I don't get it. I just don't get it. I think it's going to take a lot more discussion before I understand what the point is there. Like for me, I don't know. It's like when people say like trans people are political, it's like they're not political. They're just existing. That's it. They're just living. You know, how's that political? I don't know. But again, maybe I'm too biased to understand this type of stuff. Let me do Git status real quick. I think I've already committed everything. So let's go ahead and do Firefox build intro index.md. Nope, not MD. I meant to do .html. 1 second. Index dot HTML. There we go. All right, so I'm just gonna go ahead and start reading some of this. To be honest, look, I know this stream might be a little bit rough, but I'm just gonna read it and we're gonna go through it and we're gonna just look for revisions up until chapter 2, which is the chapter I'm currently working on. All right. 1 second. Okay, come on. There we go. Trans people are just hard to understand due to others' lack of experience of gender dysphoria. It's a trust issue. Maybe. Yeah, that's probably right. We're political because they made us political. Yeah, that's a true statement. I don't... Can you read a book while writing it? Can we read your book while you're writing it? Yes, it is currently available right now on laoslabs.com/GPU handbook. I'm going to be going through what's written there right now. Today is my goal. For the next hour and a half, I just want to read through it, revise it, make sure it all makes sense. And then hopefully, either tomorrow, I will finish up chapter 2. Tomorrow or early next week, I'll finish up chapter 2 and we'll do another stream going through that, right? I thought about maybe doing like distinct lectures on GPU computing. Like instead of just going through the book, I would instead like give a course and say like, oh, here's the state of GPU computing. Here's specifically how to do broadcasting. Here's all this kind of stuff. But the more I thought about it, the more I thought like, well, at the end of the day, maybe this is compelling content to make, but the question is, would it not be more worthwhile to just go through the material while I'm making it? Instead of waiting till it's at the end. You know what I mean? Like, why not just go through it now, talk about it, and have people help me out with this process while we're writing it. And then later we can come back and we can like do the actual lecture series or whatever we want to do with it. You know what I mean? Like, why do I have to hide it until that point is what I'm trying to say. I had been of the mind that I should hide it and just get it done. But like, I'm not a hiding type of guy. I like more people to have open conversations. And so I feel like, yeah, okay, maybe this is going to lead to a couple streams that are not exactly like super high quality. Fine, we're not doing a high quality stream today. That's okay. I think it's better just to get the stuff out there and to start talking about it. Besides, like I was saying the other day, it's very important to me that I am as transparent as possible, not only with this type of discussion, but also with like research that I'm doing and so many other things, right? And so I want to be as open as possible. And if I'm like hiding the development of certain projects behind people's back, again, you could say I'm just waiting for the release to make sure that it's as big as possible. I get that, but I also feel like, for me in particular, it makes sense to do as much as I can, as open as I can. And if that means I do a couple kind of somewhat boring writing streams, I guess that's fine. You know, it is what it is, you know? Okay. So for this, I'm just going to go and read through all of these guys. So we have welcome, reviewer's guideline, a little bit about the author, and prominent reviewers and stuff like that, and then the introduction. I think I can get through this in like an hour, and we can talk about it and see what we have to say. So, did you ever look into Bendlang or HVM2? So I don't know about HVM2, but I know about Bend, HVM2. Massively parallel optimal. What is this? A massively parallel higher order virtual machine 2 is a massively parallel interaction combinator evaluator. By compiling programs from high-level languages such as Python, Haskell to HVM, one can run these languages directly on massively parallel hardware like GPUs with near identical speedup. So it's essentially an LLVM level, but for GPUs. That's nice. That's good that this type of thing exists. This repository provides a low-level IR language for specifying the HVM2 nets and a compiler from that language to C and CUDA. It's not meant for direct human usage. If you're looking for a high-level language to interface with HVM2, check Bend. Okay, so this is what Bend uses. So I had some issues syntactically with Bend, and I have all of my eggs into the Julia basket right now. So I'm not entirely against switching languages. I've said this before, but I do find that this one right here feels to me like an MLIR approach, mid-level intermediate representation that will then kind of distribute itself out to LLVM like languages. I think Bend at the time only worked on CUDA, I think was the issue, or maybe it works on AMD as well with an OpenCL backend. I'm not actually sure. Bend language, OpenCL. 1 second. So I need to take a look at that. But does it run on AMD? Let's see. AMD? No, CUDA? Let's see. The promise is rooted in Bend's design philosophy, which combines the expressive power of languages like Python and Haskell with performance capability of lower level languages like CUDA. So it says it can run on accelerators, but I think my issue with Bend is that it only works on NVIDIA, and I don't have an NVIDIA card. I have access to one I could look at, but I don't remember all the details. But there's something about Bend that disqualified me from using it, and I don't remember what that was. Okay. Let's see. It's hardware agnostic compiler. HVM3 is pretty cool. Is a pretty cool compute model, I think. Bend is not about LLVM. It uses interaction combinators. What are interaction combinators? Bend GPU is CUDA exclusive for now. Right, so that might have been the reason why I couldn't look into it. I imagine in the future, there are situations where it would make sense to use, specifically once you get, Metal support is huge. Once you can actually get this code working on Apple Silicon, people care, because now they can run it on their own laptop without having to think about anything. That's what we saw with the Julia language. Like the moment we got Metal support, people like really started caring about the GPU ecosystem, because now you can write a single kernel that executes on your Mac laptop, and then you can throw that onto a supercomputer, and it's going to work just as well. It's crazy, like being able to do that type of stuff. So a lot of people care about performance portability nowadays, but still people seem to care more about performance than portability. And my argument is that portability actually does matter. Like people really do care about being able to run this code on their laptop. Being able to write a kernel and have it execute in parallel CPU so you can test it before running it on the GPU is great. It's stuff that I wish more languages allowed you to do. Okay, so let's kind of go through this. I think there's one thing I want to do that I don't think is on this page, but I'm going to add it today. I would like to add some sort of form to let people kind of like pre-register their willingness to buy the book. And the reason I want this is so I have some indication of how many sales I'll have beforehand, and I could maybe do a print run of it, and like, you know, maybe do some signed copies or something like that. I don't know. I haven't really thought all the way through it, but I would like to have that form available. So I'm going to read through this and see if I already put that in there, and if I didn't, I'm going to add it in. Let's take a look. Copy link. Parallel evaluator, interaction combinators. Okay, you are not scaling at all, are you, baby? Okay, let me do this. And that. Why are you scaling so badly? What is going on here? Do I have to click the plus button? Okay, what a weird interface. Okay. We present HVM2, an efficient massive parallel evaluator for extended interaction combinators. When compiling non-sequential programs from a high-level programming language to C and CUDA, we achieve near-identical parallel speedup as a function of cores available. They compile to C. No, they don't compile to C. They can't compile to C. They must be compiling to some like NVPTX dialect. Who would compile down to C? Scaling for 400 million interactions per second they have Apple though. To 5,200 MIPS, Apple M3 Max, to 74,000 MIPS. They're comparing Apple M3 to an NVRTX. What? Who does that comparison? Why would you compare an app? Mac does not even have NVIDIA GPUs available nowadays, do they? I guess maybe an Apple Max does? Maybe I don't understand. Can you just plug a GPU into an Apple Max computer? Is that a thing that you can do? Anyway, long story short, I hate it when people do the comparison between CPUs and GPUs because you cannot compare across hardware. That just does not work. But it's fair enough to talk about it when you're just trying to get people into GPU computing. I understand that. But I still don't like people when they do a GPU speed up. Interaction nets and interaction combinators were introduced by Lafont as a minimal and concurrent model of computation. Lafont proved that ICs were not only Turing complete, but they also preserve the complexity class and degree of parallelism. Okay. Moreover, Lafont argued. So the reason I'm kind of like a little bit about this is that, in general, when you take algorithms and you put them onto parallel architecture, you cannot conserve the complexity. That is to say that there are many cases, like for example, summation, where you take something with higher complexity in order to make it more fit better on the GPU. And so it's not that this is untrue. I believe it is true, but it's a little bit misleading when you start talking about complexity and then you also talk about the difference between serial and parallelism, because everyone knows that complexity notation doesn't exactly scale the same way as you would expect. Download PDF and then open browse and zoom. HTML Apple M3 uses CPU. I see. Mainly do you see like an IR? That's interesting. I would have thought you would immediately go to the lower level representation. Again, in Julia, we spit out NVPTX, or we spit out SPIR-V in some cases, or we spit out whatever it is in the AMD stack. I don't even remember what it is, but that's what we do. And it is weird to me that you wouldn't just naturally do that. It could just be because the languages that they're compiling from don't have LLVM dialects associated with them. In that case, you can't just spit out an LLVM-like language like we can in Julia. That's fair. But it seems to me like compiling to C and then compiling down to another language has an additional step. You could argue it has better interoperability with C, which is a huge programming language, and that does matter, and I'll agree with that. But yeah, I'm interested. Anyway, I think I'm picking this apart, and I should not be picking this apart. I should be reading it and acknowledging it as a paper that allows me to understand something in a deeper way. That's what I should do. But I am automatically angry at something, and I don't know why I'm angry. I don't get it, but all of a sudden I'm just picking it apart. Like, this happens every time I read papers where, like, if there's something slightly wrong with it in the intro, I get kind of real sketched, and then I'm like, uh-oh. Not that there's anything wrong with this. I believe that everything in this paper is legitimate and correct. It's just that, like, you know, like, there's like a sketch factor that's added the more you read a paper, and like, for some reason my sketch sense is activated here, even though I know it shouldn't be. HVM kind of sounds like pseudoscience though, but I think it's not. I think this is actually what's getting me, right? Because I know it's not, because we have Bend that is working, but also, like, why wouldn't you compile down to an MLIR type approach like Mojo? Or why wouldn't you compile down to NVPTX? Or why... And you could argue that maybe the engineers just didn't know about, like, these lower level, mid-level representations, and that's why they didn't do it. But why not target SPIR-V then? Because SPIR-V, at least, you know, at the very least, you know, can run on everywhere, because you can just compile down to SPIR-V, throw it into a Vulkan instance, you're done, you know, or OpenCL instance, you're done. You don't have to think about the heterogeneous programming aspect of things. So I'm quite curious as to why they chose to go down the LLVM route here, when they could have chosen to go down, like, something that can actually run on GPUs. Right? That's something I'm questioning. I don't know why. And if you guys know, I'd love to know. Because again, there's a very subtle delineation between NVPTX and LLVM. They're very similar. It's just a very subtle difference, right? And sometimes you have to, that does matter in some papers. They argued interaction combinators help effortlessly parallelize FP code. FP being floating point code. That could be true. I don't know what interaction combinators are. I need to look into them more. Okay, here's what I will say. This is interesting. I want to look into it, but what I'm going to do is I'm going to throw it into the paper pile for now, and I'll take a look at it later. So let me go here to the paper pile. Let's go paste this here. That was not what I meant to do. Wait, is it what I meant to do? No, I think this is what I want. Yeah, there we go. Right? Yeah, this is what I want. So I think I want to look into it later. Functional programming code. See, that could be the thing, right? I don't do functional programming. And so if maybe there is a different way to do parallelism over functional programming methods that I don't know about. And this could be what enables you to do better parallelism. Because if you told me that like functional programming does not enable itself to be parallelized for some reason, I'd be like, sure, maybe. I know so little about this area that I would maybe agree with you if you told me this. I would say it is a little bit sus to me, considering like the bulk of GPU programming is done through kernel executions, and kernels are essentially GPU functions. But I know functional programming is not that way, and so I feel like there must be some truth here. I think at the very beginning, Golang compiler generated C code. If I'm not mistaken, I think it's an easy way for many programmers to start language development. Probably in the long run, it usually makes more sense to switch to generating machine code more directly. Functional code is the most parallelizable. That's what I thought. Like that's what I would naturally would think. But I know so little about functional programming that if you told me the other way, I'd be like, oh, maybe. That's what I'm trying to say. Like, it seems weird, but maybe it's not. You know, that's what I'm trying to say. I really hope functional programming would take off, but currently it's unintuitive. We are used to doing things step by step, not as functions. I will say that when it comes to GPU computing, a lot of this intuition does go away, and we do have to directly tackle the fact that CPU programmers are used to writing code in a way that is unintuitive for the GPU, and the other way is true as well. GPU programmers are writing code that's unintuitive for the CPU. This is something I'm actually tackling in the chapter I'm writing right now when I talk about loop vectorization and the act of taking a for loop and turning that into a parallel executing abstraction, right? In that transformation into an abstraction that can run in parallel on the GPU, you're actually losing what a for loop means, and you're kind of overloading what this functionality means. You're muddling a lot of concepts together that should not be muddled, in my opinion. Yes, I think I said what I meant to say, but there could have been some noise there that didn't lend itself to being understandable. Folds are not really parallelizable unless it's a reduce. Yep, that's exactly what we did in Julia. So we have Julia folds, and people are... People were very into that, but the problem was, oh my goodness. So, you know how I like to pretend that academics are drama free? It's not true. It's not true at all. Let me show you something. Let me show you guys something. There's this thing that came out in Julia. Julia. Here we go. Let me see if I can find the paper associated with it. Where are we? Jack Branch, Julia oh, you know what I need to do? Let me do this really quick. Wait, I know where I can find it on Slack. Let me do this and let me show you on Slack. Where are we? Here we go. And I will give you the paper in just a second. HPC. Here we are. Copy link. Go here, paste. 1 second. Yep. There we go. And it should be up now. Perfect. This is the button I need. Okay, so this is the paper that just came out. This is the paper that just came out. And I'm so sorry. I'm so sorry. I'm so sorry, guys. I'm going to be petty. I'm going to be real petty here. So I've been in the Julia lab for a while now, since 2020, right? That's a long time to be in the Julia lab. 5 years, man. Almost 5 years. Something like this. You know, I've been using Julia for a long time. 7 years now I've been using Julia. And, you know, I've been with Julia maybe even longer than 7 years. I've been with Julia since 0.3. I'm a fan of the language. The only reason I'm using the language is because its GPU ecosystem is so well developed that it beats the snot out of CUDA. It beats the snot out of OpenCL. There is no other competitor that does GPU computing as well as Julia. So with that said, there was a paper that came out just recently. It was officially published. And here's the first sentence of the abstract. It says, "We present Jack, Julia for accelerators, the first high-level and performance-portable model for the just-in-time and LLVM-based Julia language." And I got mad. I got so mad. And I cannot explain why I got so mad. I'm not the direct developer of kernel abstractions. I did not write that API. I have helped develop it, and that is certainly a true statement. I'm one of the developers, but I'm not like the main one. You know what I mean? But when I read this, I got really pissed because the Julia language has one thing and only one thing going for it, and that is GPU computing. That's it. There's basically no other reason to use Julia in 2025. There just isn't, right? You could argue that it's good for data science and stuff like that, but no. Look, other languages beat Julia out in almost every field except for GPU computing, where it is so good. It's almost impossible to go back to other languages once you've used Julia for GPU computing, right? And yet this paper here claims to be the first high-level and performance-portable model for the just-in-time and LLVM-based Julia language. This is wrong on so many levels. First of all, it's not the first high-level and performance-portable model. Other people have already done this before. Second of all, the name Julia for accelerators indicates that Julia does not already have a very well-established GPU ecosystem, which is not true. It has a very well-established GPU ecosystem. It says Julia is LLVM-based. It is LLVM-based. That's true, but the problem is that when you talk about performance portability, you don't actually care about LLVM as much as you care about the other LLVM-like dialects that you compile down to. Just-in-time compilation. That's also not entirely true for Julia. If anything, it is just barely ahead of time. You know what I mean? This is what it allows it to get. This is what allows you to dispatch code after type inference, right? So saying it's just in time is relating it to Python, but it's not Python-like. It's, if anything, it's its own compilation structure that I'm very careful to never call it just in time. I usually say ahead of time, or else just barely ahead of time if I'm being very technical, right? It's kind of somewhere in between the two, right? And so all of this sentence was already very wrong and very aggravating. They didn't cite the kernel abstractions paper when they mentioned kernel abstractions in here. They didn't cite any of the code that they used here. And they just kind of said Jack lies on top of all this. They basically leveraged the entire Julia GPU ecosystem to write this code, and they didn't cite anybody. They didn't even pretend. Like, I don't know, it was incredible to me, right? And then, on top of all this, not citing anybody, having a whole bunch of false claims, the code's also kind of like not easy to read. They had this concept of a parallel for loop, which, for the record, there's a lot of things that you can do. You can overload a for loop very easily in Julia to such an extent that you could actually just write like a threads.addThreads. You can create a macro to use the for loop already existing in Julia and turn it into a fold, turn it into like a reduce that allows it to be parallel much easier, right? Like these type of abstractions work relatively well in Julia already, and we already have them existing, right? And so like, not only do we already have it existing, but their implementation is also like the least intuitive of the implementations I've ever seen for a for loop implementation in Julia, like loop vectorization and stuff like that. And so it's like, you put it all together, I'm like, what did they do? Here's what they did. They created this thing called a Jack array. Now the Jack array, man, this is so much annoying, unnecessary drama. So the Jack array, what this does is it abstracts out the concept of an array. Now, an array is already an abstract representation in Julia, in that you have different GPU backends. You've got Cuh arrays, you've got Rock arrays, you've got metal arrays. These are all for different architectures. And what we do is when you launch a function with this particular array type, we dispatch it to the lower level representation you need for that array type. So if you're running on a metal array, it's going to have a different lower level representation than if you're running on a Cuh array with CUDA and NVIDIA hardware, right? That's what we do, right? And so you need that type differentiation. You need this concept of multiple dispatch, where you dispatch different code based on multiple types. You need that in order to do this representation in Julia. And so all they did was they muddled up the types to make it so now it's not very clear as to what you're doing. So this situation, like imagine you have a heterogeneous environment where you have both CPU and GPU computation that you want to do, right? Or you have two different GPUs on your hardware. Well, now it's very difficult to differentiate between that different type of computation you want to do. And so it's just everything they did was like, wow. And then they just slapped us like the Julia GPU ecosystem in the face. And I just felt, I didn't know, I was seethingly angry about this. I was so mad about this, just because they had discussions with people in the Julia GPU ecosystem, and we told them about how this bifurcates the ecosystem. It makes things like a little bit worse for all these different reasons. We told them about the issues with their metaprogramming capabilities in this code and all that, and yet they still pushed through. And it just really made me angry. I don't know. I don't know how else to explain it. Let me go ahead and catch up. Folds are not really parallelizable unless it's reduced. It might be a dumb question, but if I want to dive into GPU programming from the very basics, is there a good book you recommend for some resources? Oh, I have a good book for you. It is the one I'm writing. The one I'm writing is intended to be for upper high school level, if not early undergraduate level. So the idea is that anybody who has done any basic programming before, let's say some basic programming in Python, could read the book and they could understand everything about GPU programming from the book. That's it. Have they rewritten Julia or made a library? They made a library, a package in Julia that kind of messes up with the Julia ecosystem a lot. Okay, really obvious acronym where they're a paper author. So to be fair, like, it's not a bad name. I don't mind the name. It's just like everything kind of put together was very frustrating for me. In addition, there was, I don't know if I should say this out loud. I will say this, but it might cause me to take this video down. But I will say it anyway, because I'm in a drama mood today. I'm in a very much drama mood. No, I shouldn't say it. There was some drama that went down in the Julia lab that made me very much question the research ethics of certain people in the Julia lab, and I will leave it at that, because I'm not going to say it. I'm not going to say it at all, because I don't want to. I'm not going to air dirty laundry out. This is dirty laundry that I'm okay airing out, but I'm not going to air out this dirty laundry. I'm not going to say it. It's too much. All I'm going to say is that, like, I did a rant on it on Discord. If you want to, you can look at that rant on Discord. It's under the MATLAB rants section. Scroll up. You'll see exactly what this person did. And I was very frustrated at this person. It's in a sense an attempt. Never mind. That's all I'm going to say. It's on a different server. If you want to look at it, you can. But I was very frustrated at this. And so when you added that drama to this drama, I was just very upset over this past week for a number of different reasons. Okay, let's just start reading the book, guys, because I've got like 45 minutes until I have to go. So let's read through this. Will you publish your book as a PDF? I won't be able to buy it unless with Bitcoin or something. The book is going to be freely available online for all time. There's no question it will be freely available online. That's it. It's going to be on laoslabs.com/GPU handbook-GPU handbook. I think the link is even here. Yeah, let me just give it to you one more time, just so people have it. Here it is. It's always going to be available here. That's it. You can also buy it, and I would love for people to buy it in a way that they can support the project and support me and support the community. Because going in the future, I intend... So there's something that I've done on stream that most people won't know, and they won't notice. But I'm going to say explicitly now, there are no ads on this stream, and there will hopefully in the future never be ads on my stream. I think that advertisements are bad for the creator and bad for the creator economy, and there's so many things I think are bad about that. And I do not want to force people through advertisements if they don't want to see them. However, I do need to make money somehow. And so the way I see it is I am writing these books. I'm trying to create some sort of merchandise in a way so that as I am doing more stuff, I enable people to buy things that give them tangible objects that will help them to show their support and to also learn something or else be entertained in some way or something like this. That way I can maintain like the no advertisement stance. And this actually does hurt me a lot on Twitch. In particular because it means that I can never be affiliated with Twitch and I can never be partnered with Twitch. So this means I can never make money off of Twitch as an ecosystem, because once you become affiliated and you become partnered with Twitch, you unfortunately have to put ads on your stream. And I'm so against putting advertisements on my stream because I do not support brands in that way. You know, like I don't want my brand that is Leos Labs associated with Coca-Cola who puts their ad on my stream, especially because Coca-Cola recently put out an AI generated advertisement that I'm so far against. I do not support a lot of these companies morally, and I would like a way to vet the companies that put advertisements on my stream, and that simply cannot happen from my end. That can only happen from the company's end. So I'd be willing to put an advertisement on the stream if I made the advertisement, or it's from a company that I appreciate and I respect, like Brilliant or something like this. But I'm unwilling to do it for arbitrary companies, you know what I mean? So I can buy this with a Twitch sub. You unfortunately no. It will be available on Amazon everywhere. That's one plan to distribute it, but I'll figure out that later once the book is done. I've spent so much time talking about the book and I haven't done any time reading the book. So for the record, today we're going through logistics, what's going on about the author introduction. That's what we're going through. And then hopefully we can also go through all the ways to GPU. But we'll see how far we get. I'm pretty sure we can get through these 4 and then we'll talk about everything else. It's just a bunch of little things that we want to do. YouTube literally put scam and sex ads, and I'm not even kidding. Yeah, I'm not willing to do that. I'm not willing to have my brand sullied because other people are like just, I don't know, you know what I mean? Look, your brand matters. What you say matters. You can't just throw crap out there. And I recognize I say you can't throw crap out there while doing a live stream that I know very few people are going to watch. But that's okay. You know what I mean? You can't, it's okay for me to put out content. Like the type of stuff I put out on stream, I actually stand by. Like I recognize maybe the stream content is not everyone's favorite type of content. I get that. but I do stand by the content as being good content and stuff that I enjoy and I wish more people did, right? Why can't you choose ads? Yeah, I don't know either. I wish I could just vet the brands and say, these are the brands that I want to do. If the YouTube channel ever became big enough that people were like, that YouTube comes to me and says, hey, you have to start, like, at some point, like, maybe you get like 1 billion views or something, I don't know, some large number of views, and they're like, wait, this guy didn't do advertisement. I would like to go to them and explain this is why I didn't do the advertisement. So for the record, the statistics show that you lose about 10% of your audience from advertisements, right? And so there is a mathematical way in which, like, if you look at the math, it is possible to say that removing advertisements can make you more money if the community is supportive enough and is willing to, like, it means you get 10% more sales on things, right? So if you're selling a book and that book is very much related to the topic that you're presenting, right? Then you could imagine a situation where that extra 10% of audiences also gives you an extra 10% sales on your book, which, seeds it a bit better, allows for more exponential growth in other areas. Like, there's a lot of things that you could say that 10% viewership does matter. And so I'm not entirely convinced that the extra money you get from AdSense is actually worth the cost of losing 10% of your viewership. I don't know. At least for me, when I see a YouTube ad or a Twitch ad, I just click off. I'm not willing to watch that. Sometimes I'll refresh the page like 5 times and then hope that I don't get an ad, but I'm not. I asked a question earlier. I want to hear your point of view, if that's okay. What was the question? I might have missed it. I'm so sorry. Was it about the GPU book? Yeah, wait. Repeat the question. If it's about the GPU book, I can guarantee you there are not very many good GPU resources, which is why I'm writing this book to begin with. Yeah, if it was another question, I do apologize for missing it. Just ask it again, and I'll read it through. Okay, let's get through this, and there's a couple of changes I know I want to make. We'll get through it. Let's go from there. It's about resources. So for resources right now for GPU computing, here's what I would say. Go to the CUDA programming guide. This gives you the best, like, to me, it's the best introduction for understanding the architecture that is the GPU, right? That's it. What I would say is beyond that, there are very few good GPU book resources, which is again why I'm writing this book. And that's it. I believe that once this book is done, it will have a dedicated place, like on everyone's shelf who wants to do GPU computing. And I do believe it's going to be very useful for a large number of people. Otherwise, I would not be writing it. I recommend grayj.app for viewing YouTube if you don't already. I haven't already. I want to dive into them, but I was very overwhelmed, and that's why I asked. Yeah. So if you could give me just like a month or 2 to finish writing this book, I think by March it'll be done. And you can work with me on the book as we go through and tell me what you don't understand. That would be great advice. And we can go through and we can learn things together. And I think that's actually probably the best way to do it. Did you say I will buy it? You don't have to buy it. I'm not asking you to buy it. I'm asking that the best thing that people can do if they want to support the project is to help me with the review stage, like the beta reading phase, and to tell me what you think about it. Like, that's the most important part. Okay, so let's start reading this. So what's going on? When I started my PhD in 2014, it was fairly uncommon for programmers to use their graphics processing unit GPU for any computation beyond what was necessary for gaming or some graphical applications. The world has changed since then. Nowadays, it feels like the GPU is the most important piece of hardware on any computational device, supercomputers, desktops, phones, etc. Computer-generated imagery, CGI, for movies and games have become almost photorealistic. And all the necessary computation happens on the GPU. The fastest supercomputers in the world run GPUs. Machine learning models are trained using GPUs. Everyone needs the GPU for something. At the same time, there are very few good learning resources available to teach beginner programmers how to properly use their hardware. So that's what this book is. A gentle introduction to most of the programming concepts necessary to understand GPU computing through meaningful real-world applications. There's a comma that I missed there. What did I... One second. You? Oh, I see. VI source, and this is index.md. Meaningful real world examples. Okay. All the content on this site was created by James Schloss, Laos. The code is released under the MIT license, which means you can use it for virtually any purpose as long as you attribute me and you let everybody know that my code is freely available under the MIT license for use. The text is licensed under the Creative Commons Attribution Non-Commercial Share Alike 4.0 International License CC by NCSA. This means you're free to read, copy, modify, and remix any of the text here with a few key restrictions, namely the new derivative work cannot make money, must attribute me, and must be available for free with the same Creative Commons license. In other words, derivatives of this work cannot make money and also must attribute me as well, and any additional authors. If this book is useful to you, for you, please consider purchasing when it's officially released. Otherwise, please let me know if there are any typos, errors, or jank that you find along the way. Thanks for reading, and I hope you enjoy, and I hope the book helps you in some way. Welcome to the world of general purpose graphics processing unit computation, Dr. James Schloss. Okay, so I want to add one thing, which is going to be a Google form. So if people do want to purchase a book, they can just let me know, and I can like add them. Like, you know what I mean? I just want to have like a brief, like some sort of, I want to know roughly how many people are interested in buying the book before the book comes on sale, right? Let's see. Incomplete sentence there. Which incomplete sentence? Sorry. Since we were on topic and I'm buying a GPU, am I good to go with AMD, or am I better served NVIDIA for GPU programming? That's a very good question. So right now I'm using AMD, okay? AMD typically has roughly the same level of hardware, like it's roughly as good hardware-wise. However, it lacks software support. That's the issue. Less into the second paragraph, thank you. So that's what this book is, a gentle introduction to most of the programming concepts. Oh, yeah, it is a gentle introduction. I agree with that. I'm not sure if I should leave it that way or not. But yeah, so since you're going to buy a GPU, I don't know if I'd necessarily recommend AMD, because outside of the Julia ecosystem, AMD is a huge pain in the butt to use. But when you... it does have more RAM sometimes as well, that's true. But when it comes down to GPU computing, at the end of the day, if you want to do performance engineering and stuff like that, the software tooling for NVIDIA is just way better than the software tooling for AMD. So if you're okay sticking with the Julia ecosystem, AMD's fine. It's going to serve you well. If you want to move to OpenCL, AMD's fine. It's going to serve you well. But when it comes to like the software experience, CUDA is just way better in terms of the experience of writing GPU code than is available on AMD. So you have to keep that in mind. Does VRAM come into play? It does come into play a lot of times. Like, for example, let's say you're running a simulation of some fluid, right? And you need to use complex numbers. You know, you can fit like a 512 by 512 by 512 complex floating point 64 simulation in about 12 gigabytes of RAM. Okay, I just know that off the top of my head. So if you want to do high resolution, 3D models, fluid models and stuff like that, VRAM does really come into play. It's very important to have a large amount of memory available for that type of computation. It's important to consider the amount of RAM that you will need for the simulations you want to do. There are some situations where you can get away with less RAM, in which case, fine, it's okay to get away with less RAM, right? So think about the simulations you want to do, and if they seem like they might be memory intensive, then go with more memory, right? Let's see. GrayJ can also play Twitch streams and any other platform someone writes a plugin for. That's fair. I mean, maybe that's what you want to do. In terms of like ad blocking, that doesn't solve the fundamental problem that is, I don't want my brand to be associated with ads or ads for companies that I don't support, right? So I think I have 12 gigabytes. How much do I have? Rock SMI. So I've got, on this computer right now, I have 12 gigabytes, I believe. Which is Rock SMI, not tell me how much memory I have available. It doesn't tell me how much memory I have available. Do I need to do CL info? All right, let's see what we got under CL info. We have the OpenCL 2.0, GTX 1036. Max memory allocation is this. Thanks for giving me that number, but I think it's 12 gigabytes. I think is what I've got. Here's what I want, 6700 XT. Max allocation is that. So let's just open up Julia. Let's do this bad boy, and we divide that by 8. 1.3 times 10 to the 9, which is, that's 13? Is that right? 13 gigabytes? What does 6700 XT have? Oh gosh. AMD 6700 XT. 12 gigabytes, yep. I was pretty sure it was 12 gigabytes. That seemed right. NeoFetch could have done it as well. What's the GPU? GPU is a graphics processing unit. We'll talk about it in just a second. There's actually a really good intro that's coming up. Global memory size 16 gigabytes, unless I read wrong. It was down. I'm paying arms and legs for more VRAM. Yeah, so that's the question. Do you need the more VRAM? It's up to you. I think, honestly, what typically happens for these types of computation is you have a GPU that's kind of okay on your system that can just run the code. And then once the code is running and you're pretty sure it works on AMD or NVIDIA or anything like this, then you go to a cluster like Amazon EC2 instance or something like that and you run the actual code. I'm quite glad you don't place ads, just recommending it for viewing frustrations. I agree. That's totally fair. I think, yeah. It's one of those things where people who don't know that I don't have ads on the stream, like, would not know I don't have ads on the stream. They might think that YouTube just didn't play ads. They might not even know that the creator has control over whether they put ads on the stream or not. But yeah, anyway, let's keep going. So Google Forms, let me go to Forms. And what I want to do is, I believe, copy this one. Why is it so small? Come on. Can I copy this form? Let me grab this one. And let me copy it. How do I copy a form? Script, question settings, go here maybe? Oh gosh, someone knows and they're going to be upset at me. Go here, open new tab. Does somebody know in the chat? RX 9700 has 16 gigabytes, while RX 7900 XTX has 24 gigabytes. 24 gigabytes on a card that you have in your personal computer is a lot. Like, I mean, that's actually a lot, you know? Can I just create a blank form and make it a copy of, no. Okay, let's go to Forms. Let me go here and do this. No. I know there's a way to create a copy of a form. Give me a second. Keyboard shortcuts, send. No. Does anybody know what I'm trying to do? So I have a Google form here, basically for another book that I was writing. And what I'm trying to do is I'm trying to create a copy of this book. Make a copy button on the 3 dots. There are 3 dots here. There's a make a copy. Was there a make a copy? There we are. That's what I want. And this is going to be a GPU handbook survey. There we go. Thank you so much. I appreciate that. I'm an idiot. That's okay. GPU handbook survey. This is for another book I'm writing. It's actually the fiction book I was talking about earlier, GPU handbook. This is a quick survey to see who's interested in purchasing a copy of my textbook, the GPU handbook. Okay. I'll set the prices of each book so they get $5 back. However, depending on interest, I may ask for an additional $1 to $3 for signed copies. Emails collected by this form will only be used for notifications related to the GPU handbook. And will likely only be used once. Would you be interested in purchasing a copy of the GPU handbook? All right, good. Okay. GPU kernel handbook. So the problem is, this is the GPU kernel handbook, not just the GPU handbook. But I keep calling it the GPU handbook because it's just easier. Okay, this should be fine then. Let's go ahead and publish that bad boy. Publish, and then we want to get a link. Shorten the URL, grab that bad boy, and now let's go ahead and put this into the book. There? No. This one. Okay. So, if this book is useful for you, please consider purchasing it when it is officially released. If you would like, it would be nice. How do I say this? It would be nice if you'd like to purchase a book, all right, there we go. Done. All right, so now we have the form there. For people who may or may not want to let me know, that's good. And let's go and make this smaller again. Also, let me check the link really quick just to make sure I'm not stupid. That should work. Good. Okay. That should in principle work. No problem. And let's keep going on. What do we have here? I only have Apple M1. Oh, good news for you. If you only have Apple M1, no problem. I'm pretty sure you can use metal arrays just like any other GPU array on Apple M1. Pretty sure. It might be M2 and above, but I'm pretty sure it's M1 as well. So if you have an Apple device, an Apple Silicon device, all the stuff you're doing for GPU computing in this book will also work on the Apple device. If not, you can at least do it on parallel CPU and get, see how the kernels work, even if you don't have a GPU available to use it on, right? That's one of the advantages of using Julia here. You can basically use it for anything, and that's great. NVIDIA RTX 5080 is going to be 16 gigabytes at 1,000 USD, but no European retailers, no way we're paying 1,000 euros. It's most likely going to be 1,200. I think spending 1,000 euros on a GPU is maybe ill-advised. And the reason I'm saying that is because, yes, you can get fantastic speed ups for doing GPU computing, but you don't have to get the most recent generation of GPU to do that. It really depends on what you need, right? If you absolutely need the fastest performance possible, you're probably not going to be doing that on a desktop device anyway. Probably you're going to be, asking for an Amazon EC2 instance or something like that to do the GPU computation, right? If you're trying to get, good performance for like a game engine or something, well, probably you don't want the fastest GPU anyway because your users probably don't have that GPU, and so it's nice to have a GPU that they have available that you can do a lot of testing on, right? There's very few situations where I believe you need the absolute latest hardware to run this on. If you want it because you want the speed and performance, go ahead. But for the most part, getting a good enough GPU from a generation back is probably good enough, is what I would say. But it's up to you what you want to do. It's confusing me why AMD can provide more. So AMD in general does have, in a sense, better hardware. Like the fastest supercomputers in the world right now are running AMD. That's just what it is. They're not running NVIDIA anymore. Used to be they ran NVIDIA, but now they don't. In terms of like floating point, just pure flops that you can put through an AMD, they're competitive with NVIDIA at a much lower price, right? So yeah, it's just a special, like ray tracing and like, tensor cores and stuff like that you get with CUDA, which in my opinion are not super useful for scientific computation, but it is stuff that you get if you do code from, if you write code for NVIDIA hardware. I only have Apple M1. NVIDIA seems to be all in on AI stuff too. They should recognize the need for VRAM. Yeah, so I look, I'm not a big fan of the AI stuff. I think it's kind of a weird topic that we're pushing right now. So I don't know. I don't know what they're doing. I do know that NVIDIA is one of the most profitable companies in the world. And probably what they're doing, they have good reasons to do so. Thank you for the copy button. Do you have a link to the book you're writing? Yes, it is available. The fiction book. I do have a link to the fiction book, but it's not out yet. The first chapter is not out yet. I'll let people know when the first chapter is out. And when it's cool enough, will a book cover the differences between CPU and GPU? It will talk about it briefly, but keep in mind it is a GPU book. So it will only bring up the CPU as it is related to better GPU computation. That is to say, we talk about looping and loop vectorization, and why such structures are not necessarily lending themselves to good GPU performance and stuff like that. NVIDIA has been a jerk locking some features. Obviously, I would use it for gaming too. NVIDIA is going memory heavy with the 5000 series, so they're going up to 32 gigabytes. 32 gigabytes! I mean, look, I used to tell people that the only thing that you care about when you're buying a GPU is the amount of memory that is available. I said that before. I don't say that anymore because at the time, we had like 4 gigabytes was a lot of memory on a GPU. Now it's like 12 gigabytes. Man, there's a few simulations I can think of where I can't fit at least a small scale version of that simulation in 12 gigabytes. And now people are like 32 gigabytes, and that's great. But like, that's a lot. That's a lot of memory. That's more memory than most people have on their CPU, You have to wonder, what do you need 32 gigabytes of memory for on an NVIDIA device if you're not doing machine learning models? And even with machine learning models, you typically use lower precision. So you don't really need that much memory for that either, Like, anyway, let me get some water. All right, the other thing I need to do is, should this be all capitalized? I think that should be all capitalized. There we go. I will tell you exactly what they're doing, and this is assumption. NVIDIA real customers are not us, but all AI companies, and they are effectively locking out more VRAM to the more expensive cards. We gamers just happen to be icing on the cake. Oh no, that's not even an assumption, that is true. The amount of money that NVIDIA is making off of CUDA exceeds the amount of money that they're making off of any type of gaming focused application. It's been a long time since people cared about gamers for GPUs, and I think it's one of those things, it's like a misconception that like gamers think that they actually matter. I shouldn't say that. What I'm trying to say is there was a time when gaming was the most popular application for GPUs, but it has been a very long time since that has been the case, is what I need to say. And nowadays GPUs are predominantly used in data centers. That's what they need, right? And so if that's where the most money is coming from, they're going to make cards that work for that, right? But I will say that the data center GPUs are different than the ones that you can fit into your own device. Like an A100 is quite different than 5080. You know what I mean? I'm canceled again. Yeah, I'm canceled again. Sorry about that. NVIDIA is too focused on generating fake frames. Yeah, weird stuff they're doing with AI. I don't necessarily agree with it. Data center will always win for CPUs and GPUs. Yeah, unfortunately, the market is such that they're making so much money off of data center GPUs, it makes sense for them to continue. Clipping this? Go ahead. Clip it. Go ahead. Okay, so about the author. I'm Dr. James Schloss. I received my PhD in 2019 from the Okinawa Institute of Science and Technology Graduate University, or OIST. While there, I studied quantum systems by simulating them with my graphics processing unit, GPU. After that, I've been working off and on in the Julia Lab at MIT, a very prominent research arm of the Julia programming language, where I have worked on various scientific computing projects such as climate and molecular simulations. All these projects have been done on the GPU. Though I would not consider myself to be a core developer of the Julia GPU ecosystem, I've contributed to several packages, including kernel abstractions.jl, the GPU interface we're using for this work. I also run the relatively popular YouTube channel and Twitch stream, Laos Labs, where we have been developing a book for uncommon algorithms known as the Arcane Algorithm Archive. Some of the chapters in this book were inspired by that work. I've also worked with Grant Sanderson, 3 Blue and Brown, on several projects, including the Summer Math Exposition, where we encourage thousands of online content creators to make more math content online. I don't know if this is relevant. I don't have to mention that. I've always said your research is only good as your ability to communicate it. The way I see it, there are very few people who have a deep understanding of GPU technology who are also good at communicating that understanding to others. This book is my attempt to do both. I might not be the best programmer, I might not be the best communicator, but I'm going to try my best to make this work as understandable and enjoyable as possible. Prominent reviewers. Any academic work is only as good as the peers who read and critique it. For that reason, I intend to keep a list of prominent reviewers who don't mind putting their name on this section. This should be a list of academics or core community members who have either been asked to review the work due to their expertise or have contributed significantly in the beta reading phase. So essentially what I want to do here is I want to make sure that it's not just about me, it's also about the people who I know who have read the book and they've vetted it, So like my boss is like one of the core developer or is like the person who invented Julia, you know what I mean? My best friend is one of the people who developed like a lot of the Julia GPU ecosystem. I want people who know what they're talking about to read the book and tell me that I'm an idiot and explain why I'm an idiot and fix the book, right? This includes you guys as well. If you guys can read the book and tell me what it was and what worked, what didn't work, why it worked, why it didn't work, what makes sense, all that kind of stuff. This is very important, right? In terms of textbooks, you have to make sure that you're not just spouting nonsense, right? And though I do believe I know my stuff, I also acknowledge that there's a lot of stuff that I could say that might be unfounded, right? Like I might say something that's actually technically wrong and I didn't know it. It was just an assumption I had made and I've been working off that assumption for years. You know what I mean? It's great. So will you consider in your book topics like parallel GPU setups and technologies? So I have considered this and I've been wondering how useful this is, because certainly it does matter for data center GPUs, for like MPI and stuff like that. But my question is whether it's relevant for most people who will be reading this book. And so I think what I'll do is if there's enough requests for that, I will probably do it. So what I need to do is maybe create like a request forum on GitHub or something like that. And just if there's enough people who say they want this thing, then we can start working on that chapter as well. But I will say I'm not very good with distributed work. There's a couple ways to do it in Julia. You've got dagger.jl and you've got like a bunch of other distributed libraries, but it's always a little bit annoying when you have to like work with MPI. You know what I mean? About VRAM being a lot and being enough, nowadays AAA games companies release such badly unoptimized games, and it's really, really bad. Now they are salivating over fake AI frames. This is coming from a gamer point of view. Yeah, I don't know what's going on in the gaming sphere right now. I am not very integrated with the gaming community in that. Like, I'm interested in gaming in as much as Linux ports are coming out. Like, I care about Linux gaming, but that's because I care about Linux as an operating system. In terms of, like, actually playing games, to be honest, since my kid has been born, I basically have not played any games. Even before he was born, like, my favorite game was, like, Wii Fit and like Ring Fit. You know what I mean? Like as much as I use GPUs, I'm not like super keen on like using it for game development unless it's an interesting like research question. I mean, getting real-time ray tracing at 1080p 60 frames per second is impossible without the fake frames. Yeah, so the thing about fake frames is the following, right? My question is, why do people care? Okay, as a non-gamer, I don't understand why people care so much about ray tracing here, especially because the ray tracing that is implemented for NVIDIA GPUs, and most of them are still relying on the mesh engine that is underpinning the hardware and the algorithms and the APIs and all this kind of stuff. So essentially all you're doing is you're adding like what are ultimately relatively physical shadows, but not physical enough, because to do like the blurs and shadows isn't quite right. So it's like you're making it slightly more realistic, but you're not hitting the core fundamental issue with ray tracing on the GPU, in that like meshes are fundamentally not the right structure to do ray tracing on. And like the power of ray tracing is that you're able to create like generic structures that allow you to get more precision than you would with meshes. That's one. Number two is that like the rays that are coming from ray tracing to do it in real time are usually not like recursive ray tracing methods, so you don't get the like shadows and the depth that you would expect from like a true ray tracing renderer. So it's not like the same stuff that Pixar is using to do their films. You know what I mean? So it's like I don't fully understand why people care so much about the ray tracing methods, I guess. DLSS is already 4 times upscale. Multiply that with the frame gen, and we get 64x generated pixels versus real pixel. I didn't know that. That sounds pretty crazy, to be honest. Okay, let's keep going. Next section is about the author reviewer guidelines. Okay. This book is currently in a beta reading state. That means that I'm actively looking for feedback from you, the beta reader. If there's anything funky about this book, please let me know on GitHub or Discord. There's GitHub, perfect. Discord, should just be a Discord link. Yep, good. Possible funkiness includes typos, unclear concepts, unnecessary rambling, impossible problems, and the like. Reviewer notice. I will also put a few reviewer notices scattered throughout the book for specific issues I want more input on. Please keep in mind that I'm trying to make GPU computing as easy to understand as possible. It's really hard to do this right. For example, I might over-explain a few concepts that otherwise might be seen as trivial. I might also omit important jargon that I feel is unnecessary. I'm really overly relying on you to gently nudge the book in the right direction and to welcome feedback from programmers of all levels. Prominent reviewers. I feel peer review is an essential part of any academic work. I also feel that it's important to be as transparent as possible about the review process. When the book is finalized, I will ask a few experts that I know to review the work and tell me what they think. With their permission, I will then put their name somewhere in the acknowledgements for the book, probably next to and about the author section or something. If you'd like to be considered as a prominent reviewer, please 1, review a full chapter as if it were an academic paper. I mean, really rip into the book. Really rip the book to shreds and tell me how big of an idiot I am. 2, let me know your academic background so I can include you. I will also be keeping an eye out for people who contribute substantially during the review process and reaching out to them to see if they would like to be listed as a prominent reviewer as well. I think that's all for now. Thanks for reading the book, and I hope it's helpful in some way. Okay, good. Now, onto the actual, content material. I think there might have been a typo in there, but that's okay. We're just kind of getting through the material right now. We're going to come back for, editing and stuff like that. There's some games with pure path tracing enabled, but you get the performance hit, right? Yeah, I mean, this is also the thing. The difference between path tracing and ray tracing is also, lost on some people, but really the big difference is that path tracing is done randomly, whereas ray tracing is not. That's my understanding. I might have forgotten, but that's what I think. It never looked good to me, either the ray tracing or the DLSS. The DLSS makes things look muddy, and the ray tracing looks nice, but always came at a massive FPS cost, right? I'm sure at some point, physically it will become harder and harder to physically have more performance, and AI frames will help. Here, even if 60 frames per second is boosted to 144 or 240 frames per second, it's still at 60 FPS. Sure, it's smoother, but the latency will be of a 60 FPS and even more due to processing. So I will say the following. The algorithm that I'm working on for the Quibble project and stuff like that is actually fundamentally made to allow for animations at higher frame rates, and to allow for the generation of intermediate frames much easier. It's actually created to do that. That's kind of its whole shtick. The smears and stuff like that between frames. So ideally, we come up with an algorithmic approach to address these missed frames in the middle, as opposed to trying to make AI fix this solution for us or find a solution for us. That's what I believe is the actual correct answer here. But we'll see. We'll see how impactful this paper is. I have to finish it. I've got a lot more work to do. I have to make sure it's possible to do in real time. There's just a lot of little things I have to do before I'm confident in saying that the stuff I'm working on can actually solve this issue. But we'll see. Is there a target release date for this book? The target release date will be March, April, something like this. I heard somewhere it's March and April for the start of the beta reading phase for real, and then maybe November or something for the actual purchasable release date. I heard somewhere that reasoning for ray tracing for game developers is that it's conceptually simple or something like that, such that it would supposedly pay for itself in reduced development times, even though it's not as performant. But that doesn't sound very convincing to me. I think the same sources said Pixar prefers to use ray tracing for this reason. Ray tracing allows for more. Ray tracing is physically based rendering. Okay, that's what it is. You're using a physical model of how light bounces around the scene to get a better picture of what you're looking at. Where it is specifically helpful for games is for reflections and shadows and stuff like that. It's not very good at ambient lighting because you have to do like a lot of weird things to the ray to make it so that it can actually look like, you know, foggy or whatever you need to do. But it's okay at this type of stuff. And so it's one of those situations where it can help with certain things that traditional rendering is bad at. But the reason Pixar uses it is because it's the only way to get photorealism, like legitimate photorealism for their scenes. Like, it's physically based modeling, and you just can't get the same realistic look by traditional rendering methods, right? So that's why they use it. And certainly, if you're going for photorealism in a game, adding ray tracing to it does sound like a win because it allows you to get that photorealism easier. But that's not necessarily true for all cases, right? Like, for example, I doubt that Nintendo's games, which are very highly stylized, could make proper use of ray tracing. Since you're writing a GPU book, what is your opinion on the RTX 4090 and fake frames? And when do you think we'll see some native 4K 100 FPS rendering? Again, I'm not super into gaming. I think using AI to generate frames is dumb. I really do, because the AI generated intermediate frames are usually kind of crap. And if you're doing 60 FPS and you bump that up to 100 FPS because you are generating those intermediate frames with AI, it's not great. I think we need better algorithms, and I'm developing better algorithms to do that, right? I only have a built-in chip. Is it possible to play around with the GPU, or do I need a card? Good news, yes, you can play around with the GPU. The way I'm writing this book is for heterogeneous hardware. So if you write the code that is in this book, you can run it on parallel CPU. And if it runs on parallel CPU, it should work on any GPU as well. So you can still do all the lessons for GPU computing with this book with a parallel CPU, with the assumption that you will get a GPU later to play around with. You will not get the same performance benefit, obviously, because you're using the CPU, so you don't get the same, you won't get the same scaling as you would with a pure GPU setup, but you can still run all the code. I'm not against it, just how it feels right now. What actually pisses me off is some developers are releasing bad allops and using us as QA testers instead of hiring real QA testers and using AI frames as a crutch. Yeah, look, I think you're right in that there's a lot of industry standards that need to be fixed. Can GPU be done with WebGL, Web GPU? Since everybody has a browser, it might be fine to use as an example playground. Yeah, so that is technically true. You can. So in these frameworks, you're going to be using predominantly the compute shader methodology. Like, instead of using kernels, you'll be using compute shaders. That's the big difference here, right? Ultimately, they're the same thing. Like, they will boil down to essentially the same code. So you can technically use WebGL or WebGPU for that. I don't necessarily want to do that because I'm kind of like, web technologies are great for certain applications, but in terms of providing the key intuition to teach people what they need to know to use GPUs, I'm not entirely convinced that going the web-based approach will enable that to happen, because there's a lot of like additional web stuff you have to consider now. Whereas with the Julia ecosystem, you can just start writing GPU code immediately, right? It's super easy. You can't, it's just too much boilerplate in these other APIs that make me not willing to use them for this book. However, I openly acknowledge that I'm willing, that other people, it's great exercises for other people to rewrite this book in those languages. And like I said before, I would love to be able to tie this back into the algorithm archive where you could dynamically switch between different APIs in a much easier way. That'd be cool. And so this is kind of stuff that, like, it would be nice if we could do that. But I'm not entirely sure the best way to do that right now, in terms of like language switching and stuff like that and how to integrate that. Yeah, that's where I'm at with that. You can technically use WebGL and WebGPU for this. It's a little bit extra boilerplate, maybe a lot of extra boilerplate for these situations. A lot of gamers will love you when you release that algorithm. Intel HD. Yeah, the issue though is it's not going to be easy to transition from a traditionally mesh-based approach to the approach that I'm using. It's quite a complicated transition. So this is why I want to make sure all my T's are crossed and I's are dotted before moving forward. Intel HD integrated, yeah, you can use that. Again, it's not going to be as fast, but you can still get parallel CPU performance, which is pretty good. Okay, I'm going to try to get through this. Keep in mind, I do technically have to go relatively soon, but I think I can at least get through the introduction. And then we'll talk about Chapter 2, maybe tomorrow. I'm not sure when we'll talk about Chapter 2, but I'll briefly highlight what we're talking about Chapter 2. So this chapter, the next chapter that comes up, is about actually using your GPU. It talks about how you actually use it in Julia. It gives you some problems that will be using your GPU and stuff like that. So basically, once you get through Chapter 2, you have read everything you need to learn. Like you've read up to the point that you should be able to use a GPU for some legitimate problems. Not all problems. There's a lot of things that you're missing, and it's not like this is enough to get you through like your PhD, but it should be enough to get you started and to get you interested, right? For now, we're just talking about the intro, which is going to be just the general like the state of GPU computing as it is now. And I do agree that this chapter is a little bit of fluff, and I need to cut it down, but I'm not entirely sure how to cut that down. Intel HD integrated. I was watching a YouTube video, and they had this really cool fluid simulation on the GPU. Do you do something like that as an example? I wasn't going to do fluid exactly because there's a lot of complicated physics there, but I was thinking about MD, molecular dynamics, which is much easier because you only think about one force law. But we could add fluids. Yeah, why not, right? I've done fluid sims before. And in particular, doing a pseudospectral method for a fluid simulation is not bad. We did the split step method already on the algorithm archive. We could do it. Yeah, we could do it. Let me think about what we want to do when we get there. We still have a lot of other examples to get before you get to fully integrated examples like that. So, why should I care about graphics? During my PhD, I got this question a lot. To be honest, it's a good question. If you're a scientist that studies the motion of galaxies or some similar problem, why would you care about the latest animation from Pixar or DreamWorks? Well, let's talk about that. As a reminder, GPU stands for Graphics Processing Unit. Historically, its purpose has been to do graphics, games, visualizations, graphics. These workflows typically require a lot of simple operations. For example, we might need to move a bunch of points from one set of locations to another, or color a bunch of pixels red, or any other color, or track a bunch of rays of light bouncing around a scene. It's not particularly difficult to whip up some code in Python, C, or Julia to solve these problems for us. The trouble comes from the fact that these operations often need to be done a lot, thousands or millions of times. We also usually need the results immediately, like within 1/60th of a second. When there are a large number of operations and a really short time limit, it suddenly makes sense to offload computation to a separate device that is built for that kind of work. That's what a GPU is, a separate device that is built to solve a lot of simple operations at the same time. I need to stop and expand upon the three separate claims made in the previous statement. 1. The GPU is a separate device. This means that we often need a special protocol to use it from our programming language of choice, and we need to think about how to transfer data to and from the GPU. 2. The GPU is built to solve simple operations. This means that certain workflows are not well suited for the GPU. We'll give more examples of these later in the book. 3. The GPU is built to solve a lot of operations at the same time. This means that we need to actively think about what each computational core of the GPU is doing in parallel. I've often said that research in computational science mirrors research in computer graphics. Computer graphics researchers generally work on hardware and software tooling for GPUs, small parallel devices that can fit on modern motherboards. Computational scientists generally work on hardware and software tooling for supercomputers, large parallel networks of computers strung together to solve difficult problems. In a sense, both groups have been attempting to do the same thing, break up complex tasks into simpler ones so they can better make use of parallel hardware. Eventually, the two forces met, and general-purpose GPU computing was born. Nowadays, the fastest supercomputers in the world use GPUs for computation. It's pretty clear that the GPU does more than just graphics. All right, I think that's a pretty solid start. So what if I actually care about graphics? Do you think QM hybrid computer would only need a GPU and no classic CPU? That's a very interesting question, because for a quantum mechanical based hybrid computer, we need to consider what that hardware would look like. And I'm not entirely convinced that's going to be silicon based. I feel like if we go that way, it might actually be photonic in order to do that correctly. And if we look at the trends in the consumer economy and all this kind of stuff, it seems like the CPU is almost on its way out. People care more and more about parallelism than they do about single beefy GPU cores doing a lot of computation. You know what I mean? So people have joked and they said that in the future, instead of having a GPU connected to the motherboard, like the CPU first and the GPU second, it's going to be the other way around. We'll have the GPU first and the CPU second, right? And you can see this trend, happening all over the place. Like the Apple Silicon, one of the big things that they did is they allowed the GPU cores to be more easily accessible to everyone, right? And so as we move into the future and we start talking about this new hardware, it could be entirely possible that the new hardware is much more parallel and in a sense emulates a GPU. And by the time we can integrate it with a quantum processor, could be that it's basically a GPU without a CPU attached. This is all the more reason why parallelism matters and why this book matters, because when it comes down to it, GPUs and parallelism are probably one of the most important concepts for early programmers to grapple with and to understand. And to provide the ability for them to understand this at a high level or at a way that, anybody can access is very important, because it's one of those things that isn't taught super well at an undergraduate level. And it'd be nice to have additional books that can do that teaching, right? To me, this seems true. You can do a serial computer. You could do a serial computer on parallel GPU, but not great the other way around. Let me reread this. To me, this seems true. You can do a serial computer on a parallel GPU, but not the other way around. It is kind of true. The big difference is that you have a bunch more cores available on the GPU, right? You do, just a bunch more. But these cores are not necessarily good at all things. And so there's some applications, like for example, summation, where you don't want to do summation all on one core, right? Where on the CPU, it's literally just adding all numbers together. It's like 4i is equal to 1 to 10, 1 plus 2 plus 3 plus 4 plus 5. You don't want to do that way on the GPU because each core is so weak that it's unlikely that you're going to beat CPU performance by just doing the naive thing. You have to kind of think about it in a little bit more detail. So this is what I meant when I said that certain algorithms are not very well suited for the GPU. You have to rethink some algorithms in order to fit it there. And so in general, it is true that you can map one CPU core to one GPU core in principle. In practice, you find that in order to make best use of the hardware, you do something slightly different. Okay, but what if I actually care about graphics? Another great question. This book is specifically written for students who want to use their GPU for more general applications, like large-scale simulations. It is a little unfortunate that the programming interfaces for graphics are typically quite different than those used for computing. If you're interested in building a game or rendering engine, it might be best to think of this book as a way to satiate some idle curiosity that might be lingering in the back of your head. It's all good to know, but it's okay to read it for fun instead of rigor. That said, there are still a number of good reasons to keep reading. One, it's entirely possible to use the lessons learned from this book to do software rendering, which can be more flexible than traditional graphics workflows. Two, we'll be discussing several graphical applications that are well suited for compute workflows, such as ray marching and splatting. I need to rewrite that one. Content, is it just 1.md? No, what is it? It's, what did I call it? Abstractions? No, it's going to be intro. Graphics. Next. Okay, so that question was, we'll be discussing several graphics applications that are well suited for computational workflows. Several graphical applications that are well suited for computational workflows, such as ray marching. Maybe that's okay. Computational workflows, such as ray marching and splatting. Even within traditional graphics workflows, there are several applications known. There are several applications. There are certain functions. There are functions known as. Certain applications work right. Certain applications. There's certain applications. Oh my goodness, you're kidding me. Certain applications that use compute shaders. Even within traditional graphics workflows, there are certain applications that use compute shaders for various reasons. Volume rendering and particle systems both come to mind. Compute shaders are almost identical to the functions that we will be writing in this book. This book should give you some key intuition about how and why the GPU works the way it does, which could be quite valuable for performance engineering down the road. And 5, we will discuss the abstractions used in graphical GPU interfaces in the next chapter. Will we though? Did I actually add that in? I don't think I did. Yeah, I don't think I did. I want to remove that because I don't think I want to talk about it in the next chapter. I want to talk about it later. But there is a larger question here. Why is there such a big difference between interfaces for graphics and interfaces for computation? After all, we're all programming the same device, right? At the end of the day, it's all GPU. Well, this brings up something that I really have to say before continuing further. There we go. An unfortunate truth about GPU computing in 2024 that all students must be aware of before proceeding further. No matter what language, interface, or method you decide to use to program your GPU, they all share one thing in common: jank. Simply put, GPU interfaces are way less polished than you might expect when transitioning from traditional CPU programming. Some of this is because GPUs are inherently parallel devices, while CPU code is often written without parallelism in mind. But I would argue the majority of programmers struggling with GPU programming in 2024 are not necessarily struggling with concepts, but instead limited by the software used to implement those concepts. I think now is a good time to talk about GPU computing, talk about the GPU ecosystem as a whole, and in particular, the big green elephant in the room. Okay, so a couple things here. One, I should probably change 2024 to 2025. But I wonder if I should, maybe I shouldn't. Okay, it's okay. I was thinking maybe I shouldn't put a year on there at all, but I'll leave it in there. To me, this seems true. GPU core is like a toy compared to a real core. Yeah, this is a true statement. There are some GPUs now that have like hybrid computational models between CPU and GPU, and that's quite interesting. We'll see how it goes. Leia's being productive today. I'm trying. I'm very mildly productive. You know what would be nice if you showed us the lowest level code that runs on the GPU, because that gives a taste of how it really works. Just expose us a little. So that depends on where you're coming from. It could be LLVM. It could be SPIR-V. Or method you decide to use for GPU programming. Let's see. For GPU programming. Yeah, that's fine. Yep, I prefer that. Thank you. Yeah, so when we talk about the low-level representation, keep in mind that these lower-level representations, again, like SPIR-V, LLVM, these are not really intended to be human-readable. And because they're not intended to be human-readable, it's very difficult to learn from them to any like appreciable degree, right? I'm not saying you can't. I'm just saying that like they're not intended to be used to learn from. I think there could be something to learn from there, but usually when people boil down code to that level, they're really looking for like explosions in LLVM code, like why writing one function is like, 1,000 lines long, or writing another function is like 1,000,000 lines long, right? Like this is what people typically care of when they look at code at that level. And you can learn a lot from this, but I don't know if it's necessarily the best learning exercise to do, but it is something that we should probably put down and think about in the future. Okay, so big green elephant in the room. This is where I'm a little bit rambly, and I feel like I should remove some of this writing, but I'm not entirely sure how I want to do this. So every now and again, I'll get stuck on a problem. It happens to the best of us, and I'm certainly not one of the best. There are many different strategies to getting out of such a rut. Some people might take a walk and think about something else for a while. Others might drill down and try to find another solution from a different angle. Still others might rip off all of their clothes, jump in the bath, have a deep, insightful conversation about their problem with a small yellow duck floating next to their head. I guess I usually take the last approach, except I'm usually fully clothed and not usually submerged in a body of water, and my yellow duck is actually a bunch of random people who listen to me ramble about useless things while live streaming on Twitch or YouTube. While streaming, I would often get asked questions. Some were useful, some were not. But some questions were repeated time and time again. One such question was, as a beginner, how do I start programming? It's a really good question without a clear answer. I would often say, the only way to start programming is just to start programming, and then follow up that statement with specific projects the person could work on it to get them started. I find that working through a few meaningful examples is always a good way to start learning anything, and have structured this book around that theme. But there's something deeply wrong with my statement. If somebody is truly starting with absolutely no knowledge about programming, how do they even know where to start? What programming language do they use? What development environment? What concepts should they target first? These are all good questions. And in fact, might be the very same questions you're asking yourself right now when it comes to GPU programming. As hard as these problems are to answer, for most people, there are a few good starting points. You can't go wrong with Python or Julia as a starter language. If you want more rigor, go C or C++. If you want an active community, go Rust. Some game devs might consider C#. Web devs, honestly, should talk to someone else. There are many such recommendations I could make based on the student's specific goals. But when it comes to GPU computing, there are no clear-cut guidelines. In fact, in 2024, there is no single language that I can truly recommend. For those who know GPU computing, you might be raising your eyebrows at that previous statement. After all, there certainly is a single programming interface that has dominated the GPU space for literal decades. It has so much market share that the company in charge of its design is now one of the most profitable companies in the history of our planet. Yes, I'm talking about NVIDIA and their programming interface, CUDA. Yet, the fastest supercomputers in the world today, in 2024, do not use cards from NVIDIA and are largely unable to run CUDA code. If you're a research scientist targeting these devices, it might be a good idea to choose another language. And what about real graphics? What if you want to make a game or animation? Well, you'll probably be using OpenGL, DirectX, or Vulkan. More accurately, you will probably be using some sort of graphics, a game or graphics engine built on top of any of the aforementioned tools. Regardless, it's pretty clear you will not be using CUDA. If you want your code to run on a smartphone GPU, CUDA is not suitable. If you want the code to run performantly on a parallel CPU configuration without having to rewrite everything, yet again, CUDA is not suitable. If you have an AMD, Intel, or Apple Silicon GPU, yet again, CUDA is not suitable. Now, please keep in mind, I'm not discouraging the use of CUDA. It's a fantastic language that has been the unofficial king or queen of GPU computing for a long time, and there are a lot of good reasons for that. In fact, I am actively encouraging you to rewrite all the code in this book in CUDA if you want. I'm mainly just echoing the point I made before. The current state of GPU computing is messy. Even though most programmers go with CUDA by default, it doesn't mean that CUDA is the best tool for every job. I think it's worth spending a little time talking about this problem in slightly more depth. Okay, so this is a little bit rambly. I acknowledge it's a little bit rambly. Usually streams are full of ramblings, rambling, and derailed rambling. Yeah, look, you guys are clearly the audience that might go for that type of thing. It's a style that's good for videos, but maybe for text, it's better to go straight to the point. Yeah, so the thing is, I think I need to remove this section. It's just, so the reason I brought this up is because this question of, as a beginner, how do I start programming, is a very good question to start, right? And I think it brings up a core problem that a lot of people have when they go into GPU programming. I also think there's a couple of jokes beyond this one that I put in there that I thought were kind of funny. Like, for example, down here, I was giving examples of different languages that you might consider, and I said web devs honestly should just talk to someone else. Like, there's a couple other points. I don't know. I don't mind it. What I think I'm going to do is I'm going to keep it in for now, and then I'm going to remove it later as I do like a full review later, because there's some other stuff in here that I think I should remove it. I know I should remove it, but I don't know what I want. If I'm going to keep it in for now and remove it later is I think what I'm going to do. How do I stop programming? I don't know. I don't know how to stop programming. Also, I uniquely feel that this type of content is not good for videos and is better for text-based content, because videos, you should go straight to the point and you should not ramble. Stream is fine. But, you know, in terms of like standalone video content, you should never ramble. You should always do the best you can to present the topic in as simple of a form and straightforward a form as possible, because you do not control the pacing. Whereas with reading, you do control the pacing. So it's okay to add a little bit of fluff. But like, this is too fluffy, and I acknowledge it's too fluffy. I'm just not sure how I want to rewrite it. I think the points are clear here. One, it is very clear that how do I start programming is probably the question that most people are asking. Two, there is a language that has dominated the GPU space for a long time, and that is CUDA, but it's not suitable for all questions or all problems. And so we need to talk about that fragmentation and why it's important. So the fragmentation of modern GPU interfaces. When you buy a CPU, it doesn't matter whether you buy one from AMD or Intel. Both will work approximately the same, regardless of whether you're using Python, C, Rust, or any other language. Unfortunately, that is not the case when it comes to GPUs. Everything is a complete mess, and it's really hard to navigate for new programmers. In this section, I'm going to do my best to explain that mess without also overwhelming you with too much information. Please bear with me. As stated before, CUDA only really works on NVIDIA devices. ROCm is probably the closest to CUDA you can get on AMD cards. If you're running a modern Mac with Apple Silicon, then you will be encouraged to use Metal, which is a hybrid graphics and compute interface. None of these languages talk to each other. You can't run Metal on NVIDIA cards. You can't run ROCm on Macs. But what if you're writing real software and have multiple users, all with different hardware? One might use a Mac, another might use an Intel GPU, another an NVIDIA one. What do you do? Good question. Really good question. Let me know when you have an answer, because I'm interested too. The way I see it, there are two solutions. One, support all of the device backends for each individual use case. Or two, write your code in a cross-platform interface. I think option one is self-explanatory. You have to maintain some CUDA code for NVIDIA users, some Metal code for Mac users, some ROCm code for AMD users, and so on. Basically, anytime you need to change one of your GPU functions, you need to copy that change along all the other vendors to keep your users happy. It's a pain, but doable. It just requires a lot of testing and a few afternoons of debugging for each backend. But there must be a better way, right? Kinda. Cross-platform GPU interfaces allow you to write functions that run at essentially the same speed as vendor-specific APIs like CUDA. But those functions are not limited to specific hardware. So the same code, yeah, that's a run-on sentence. So the same code can run on AMD, Intel, Apple Silicon, and NVIDIA hardware. Same as we use Python. So the same speed. This means that. This means that the same code can run on AMD, Intel, Apple Silicon, and NVIDIA hardware. In fact, many cross-platform interfaces allow for that same code to run in parallel on the CPU as well. The Open Compute language, OpenCL, can even run on many cell phones and field programmable gate arrays, FPGAs, which are separate devices used in completely different types of problems. Used for completely different types of problems. In completely different problems for performance reasons. Either one's fine. Wait, what's this? I believe that goes away after some time. Yeah, I had a friend who had like really bad carpal tunnel, and it sucks. Like, I actually had to do a lot of programming for him for a while because his hands just didn't work. So what's the catch? Well, it's hard to overstate how incredibly dominant CUDA has been in the GPU space for so many years. Sure, you could write your code in a cross-platform way, but why would you? You'd be taking a small performance hit, something like 10%, and it would take an extra week to write your code. It'd take an extra week to write your code. Plus, all the common GPU programming guides are in CUDA. Time is money, and it takes time to learn. From a business perspective, it's better to just pay an extra $100 for an NVIDIA card and save yourself and your employees the hassle. To reiterate, almost all non-CUDA interfaces have the same drawback. They're not CUDA. This means that they are there's less documentation available. The code will be buggier with less developer support. The experience won't be as smooth as CUDA. In a world where everyone is trying to get the absolute best performance possible as quickly as possible, these are huge issues. Long story short, it's impossible to talk about GPU computing without acknowledging the big green elephant in the room, CUDA. Still, I have no idea who's reading this book or what devices they have available. I can't count on everyone having an NVIDIA GPU to use, and for that reason alone, I do not feel that CUDA is suitable for this work. That said, I'm certain everybody will have some device at their disposal that can run GPU code, so focus on languages, or rather a single language, that I'm confident the majority of my audience can use. Yeah, this is way too rambly. I think I made the point too much. So this point about CUDA being like not useful for certain topics, I come back and say, but on the other hand, CUDA is the most useful language. It's too rambly. I need to figure out a way to kind of splice these two things together into a single paragraph. That's what I need. Probably depends. It's odd that they just didn't use C language for the GPU. Well, CUDA is essentially C on the GPU. Again, the main reason they didn't is because you need a different lower level representation for GPUs. But yeah, CUDA is essentially that. But it's not standard on all GPUs. It's not a standard on all GPUs because NVIDIA specifically did not want it to be a standard, right? So they are playing this game where they know they have the best software, and they're holding that software hostage for only their own users, right? So like AMD users can't use CUDA because NVIDIA will not let AMD users use CUDA, right? It's one of those situations where like they're like manipulating the market to make sure they're on top. Have you seen Quantum Odyssey game? I have not. It teaches quantum computing. I think you might like it when it releases. I haven't, but we'll take a look later, but I might be interested in it. There was actually a bunch of people who were doing like gamification of science a while ago. It was really cool. They were essentially having people solve like a it's not a spatial adiabatic passage. It was more of like a what is this? They're basically moving the trap around and having the atom, the wave function of the atom, move around with it, and gave people core intuition about quantum mechanics. It was pretty cool. NVIDIA wanted it to be a standard, even said other companies could use it, but no other wanted because they'd always be lagging behind CUDA and NVIDIA. That might have actually been the reason. I might be misunderstanding what happened. I really thought it was NVIDIA not letting other people use it because there was the CUDA, whatever, there was the one group who basically allowed you to run CUDA on AMD, and AMD shut it down for copyright reasons. So I don't remember what it's called. Fluda? I don't remember. It was something like this. I don't remember what it was called. But that was cut down for legal reasons, right? No, it wasn't HIP. It was... No, I don't remember what it is. Zluda. That was it. This one. This is what I'm talking about. Yeah. It's literally CUDA for non-NVIDIA devices, and it's no longer in development. Or at least that's what I understood. Yeah. Anyway. It is what it is. Let me go ahead and get through this section, and then I think we'll call it a day for today's stream, and we will talk about what to do from there. Is all computing physics? That's a good question. I don't know how to answer it. At the end of the day, like computers are based off of physics, right? Like you have transistors and stuff. That's all physics, right? Analog electronics, that's physics. Simulations of physics are done all the time. People care about graphics, and they're doing physically based rendering on graphics. I don't know. I don't know how to answer that question. But certainly there is some computation being done that is not necessarily physics, right? Like this graph theory stuff, which is math. I don't know. It's you could argue a vast majority of computational code is physically based. Even if it is doing chemistry, it uses a lot of physical, like physics related methods to do that. I don't know. Hip is CUDA on RockM. Yeah. I put the link to game in the Discord. Yeah, thanks. Maybe if you go into the quantum stuff, I read that they did a computation that is impossible unless there's a multiverse. You're talking about the Willow stuff. What a crazy PR move that was. Google continually does stuff with quantum computing where they have like a very small like advantage, if anything, and then they're like, we have done something that is impossible to do on any architecture that exists today or could theoretically exist in the future. So no, stop. What you did was potentially interesting, but it was not. No, it's not like it was unknown before you did this, right? I mean, we knew that you were working on it. We knew you would do it. Like, I don't know. It's kind of crazy. I had a full discussion about Willow I was going to do, but I decided not to do it because I couldn't do it without getting angry. Haven't seen you in almost a year. How you doing? Workride, what's up? Yeah, it's been a while actually since I've seen you live. Look, it's hard to stream. Like, it's hard to find people live when I'm streaming in this time zone. I get that. There's a lot of stuff going on. Okay, if not CUDA, then what? After a lot of thought, I settled on using Julia and the kernel abstractions.jl package for this book. There are benefits and drawbacks of this choice, which I could ramble about for hours, but in short, Julia provides 1, a flexible software ecosystem that works on any GPU vendor, AMD, Apple, NVIDIA, Apple Silicon, Intel. The ability to write code that can execute both on the GPU and in parallel on the CPU at the same time, a way to execute GPU code without writing GPU-specific functions or kernels, and a straightforward package management system, a package management approach, so users don't have to think about library installation. There are a few other benefits, but this specific combination of useful features cannot be found anywhere else. To be clear, the Open Compute language OpenCL also shares many of these advantages, and even has a few distinct benefits over Julia as well. Unfortunately, OpenCL is a little less straightforward to use. The way I see it, this book is about teaching GPU concepts, and the Julia GPU ecosystem allows me to quickly do just that. If I were to write this book with OpenCL or even CUDA, I would need to spend a significant amount of time explaining syntax and odd quirks to C, or God forbid, C++, that I just don't want to deal with. Again, I'm actively encouraging you to rewrite this entire book in the language of your choice. For me, I'm planning to stick to Julia, but there's a core limitation to this choice that I'll mention at the end of this chapter. Did I mention at the end of this chapter? I'm not sure if I did. What was the core limitation I was talking about here? I don't even remember. I think I just need to remove that sentence. What was I talking about there? Also, to be completely transparent, I've contributed to the GPU ecosystem in Julia in several ways, including the kernel abstractions package we'll be using for this work. This could be seen as a net benefit. After all, how often do you get to read a book from a developer of the API you'll be using? On the other hand, I need to acknowledge my biases here and let you, the reader, know that several of my opinions might be a little too favorable towards Julia, and that your day-to-day experience with the language might fall a little short depending on your familiarity. On the other hand, I really do try to be as objective as possible when talking about projects I'm passionate about. There's nothing worse than being sold a tool you can't actually use in practice. That's why I'm absolutely encouraging you to take the code in this book and rewrite it in a language of your choice. I've mentioned that too many times. All right, that's enough rambling. We'll be doing a lot more later. Now let's talk about the general structure. Okay, so there's a lot here that we need to do. Too much rambling. General structure. Talk about the. All right, so a couple things I need to do. The first of which is I need to go up here, and I need to add a reviewer notice here. Like, what was I talking about? I'll be fixing this before I commit it. I'm just putting this down so I remember to look at it later. And the other thing is up here. Where do I want to put this? I want to put a reviewer notice in here where I think I can delete this whole section. And I can just leave it. All right. All right, so a couple things I mentioned. One, way too much rambling. I need to just remove a lot of it. And two, I need to, I need to figure out what I was talking about down here. There's some stuff that, like, the fact is I wrote and rewrote this. And, when you rewrite stuff over and over and over again, it's very clear that sometimes things fall through the cracks and you say stuff that you forgot, stuff like this. So it's good to go through that, and we need to fix that. What kind of things can you build if you know how to program GPUs? Like, does it make sense to learn GPU programming for, let's say, creative coding? It depends on what you mean by creative coding. Like, pretty much all AI stuff runs on the GPU, right? That's one thing. Most graphics workflows run on the GPU. Pretty much everything runs on the GPU nowadays. What I would say is that learning GPU programming does a couple things. One, it teaches you how to think in parallel. Right? I think that's fair, and that's something that everybody needs because no one is writing code for a single core anymore. The other thing to point out is that by doing GPU computing, you are enabling yourself to use algorithms that are like more or less commonplace in other fields. And so it's like, if you want to do ray tracing, to be honest, do that on the GPU. If you want to do like signed distance fields, right? So this is a way to do ray marching that will allow you to like mathematically represent characters. Here, let me just show you. Oh my goodness, I'm so sorry. My nose is very sniffly. Videos like so. This was created. Oh, hello. That's not what I want. I'll just go back here. So this character here was created via exclusively GPU computing. Essentially, that's what they used. Okay, it was technically a fragment shader, but the methods that you use to generate this could be done with GPU computing without any compromises, right? And so doing software rendering approaches can be done with GPU computing. Now, for the record, most of the time, if you're going to be doing graphics engines, you're probably not going to be using this type of stuff, but it's possible to do this type of stuff. And so it enables you to do stuff you wouldn't be doing before. Let's keep going. What are the advantages of learning, let's say, CUDA compared to GLSL or compute shaders? Good question. So the advantages are the following, right? CUDA can be used for fluid simulations. It can be used for anything with FFTs. It can be used for cuBLAS. It can be used for, like, if you're doing simulations, right? CUDA is better for simulations. If you're doing graphics work, openly acknowledge, probably you want to learn Vulkan, or you want to learn OpenGL or something like that. If you're doing graphics work, it makes sense to use a compute shader because they're the same thing as the kernels, right? But if you don't want all the boilerplate associated with the graphics workflow, right? You don't want to think about vertex shaders. You don't want to think about fragment shaders. You just want the compute. CUDA will give you, in general, faster performance. Not all the time. There are some situations where Vulkan can give you faster performance than CUDA, but for the most part, it gives you faster performance, and it enables you to write code in a much more intuitive way than you would if you were going through the graphics API. That's it. That's the reason. If you want to do tricky stuff with compute kernels, it's easier to do tricky stuff with compute kernels than it is to do with compute shaders. That's the reason. The quantum mechanics intuition stuff sounds interesting. I've had this crazy idea that if we made toys games that incorporate analogs for advanced science results, like relativity or quantum mechanical effects, maybe we could raise kids that have way better intuition than others on such things that are famously unintuitive, where education on them generally includes needing to unlearn old intuitions. I think these kids could then skip that step. Yeah, I agree with you there. Even in terms of GPU computing, like there's a lot of CPU programming that people know that you have to unlearn for GPUs, right? And it's this stuff happens all the time, right? Now, you could argue that still is best to learn CPU programming first. I think I acknowledge that. But there's a lot of situations, like you mentioned, where like the intuition is necessarily wrong in certain areas, and we should be enabling younger kids to learn intuition for multiple areas at the same time. That's kind of the point of this book. I want to introduce this at like a lower undergraduate level. So they've done basics of programming, like they learn Python, then they do this book, right? It should be a relatively simple advancement. Like they don't have to think about, it should be readable from any level is my hope. We'll say. How much effort would it be to write Stable Diffusion, for example, in CUDA, so you can use diffusion without PyTorch? I don't know anything about Stable Diffusion or anything about AI. Look, I've done AI models before. It's not super hard to do ML methods on the GPU. I've done it before. but I don't really know how Stable Diffusion works underneath, so I can't explain that one. Nor am I particularly interested in doing that. I don't cover AI in this book, if that's what you're asking. Maybe in the future, if people are interested enough, I could consider adding AI methods to it, but I don't think it's a worthwhile adventure for most people doing GPU computing, right? My goal is to cover core concepts that you could need and go through examples that you could use, like to learn those core concepts, right? So we'll talk about like different algorithmic approaches to summation and stuff like this. That's useful. Everyone needs to know this, right? Because it teaches you how to rethink about algorithms for the GPU. You need to learn about shared memory, so do histograms and stuff like this, which will enable you to learn how to appropriately use different memory tiles. We'll be doing like molecular dynamics and stuff like this for a very clear and easy way to do like particle sims on the GPU, like stuff like this, like stuff that like will teach you a very specific lesson that you need to learn, that you can then carry those lessons forward to use for other projects. I spend a lot of time thinking about what specific things I want to add. Something like splatting, I kind of want to add, and I've mentioned that I'm going to add because I think it's quite relevant and it's very useful nowadays when we think about like histograms and stuff like this. Like histograms are uniquely bad on GPUs, and we need to explain why. It's mainly because of atomic operations and stuff like this. But long story short, the point is to provide examples where you don't need to think too much about the example, and it gives you a lot of advantage in learning how to use the GPU, right? For machine learning methods, the machine learning itself is already complicated enough that it could like be its own book to learn machine learning. And so to incorporate that in a book about GPU computing, it's kind of like, I know it's a bit much. I'm not saying it's wrong to do so. I'm just saying that like you would have to find a very precise exercise where you could implement it as needed. And maybe that has to do with like reinforcement learning. Like I could imagine doing reinforcement learning on the GPU. That's very useful. We could think about that. But this isn't an algorithm book, it's a GPU book, right? Okay, so general structure and limitations of this book. As much as I hate to say it, our time on Earth is limited. It goes without saying that there are things I can cover and things I can't. My ultimate goal with this book is to provide a quick start guide for those wanting to learn how to get started with GPU computing. That means that I intend to cover a number of core ideas and concepts that are necessary to consider when trying to achieve good performance on the GPU, as well as key applications that I find interesting and useful for a diverse background of research fields. To do this, I have more or less structured this book around interesting key examples intended to demonstrate the lessons learned. Intended to demonstrate the lessons I would like to teach. There will certainly be areas I will miss, but I hope the areas I get to will be generally useful for the most people possible. Reviewer notice, I'll be coming back to the section later with a full overview once the chapters are more or less finished. It's also important to discuss several known limitations of this book. One, we will not be surveying different languages. This book is primarily intended to teach concepts over code. Once you master everything here, it should be relatively straightforward to translate it to whatever language you need for your final application. With that said, I will be highlighting languages and their differences as they become relevant for their respective sections. So this means that I'll talk a little bit about OpenGL, I'll talk a little bit about Vulkan and Cocos and stuff like this. Two, we will not be discussing specialized hardware that certain vendors add to their GPUs. This means no discussion, for example, hardware rasterization, ray tracing, except in software or tensor cores. We will not be analyzing performance via NVIDIA-specific tooling like Nsight Compute. I simply don't think it's fair to have a chapter on performance analysis that only works for NVIDIA devices. With all that said, I think it's time to finally start coding. In the next chapter, I'll be introducing several core abstractions programmers use when writing GPU code and getting you started in running that code on your hardware, whatever that might be. Okay, so the next chapter is actually pretty well sussed out. I think it's like 7,000 words long. It's I think at the level that I want it to be at, and it actually does get you started with GPU programming. It's really quite well done. I think it has everything we need in it, but I'm not going to be able to go through it today. I think today I did a pretty good job of going through the introduction and stuff. I think I need to rework some of it. Like there's a lot of just nonsense that I need to remove and like rework. So hopefully tomorrow before stream, I don't know if I'm able to stream tomorrow because I have meetings. Hopefully before the next stream, might not be tomorrow, might be on Monday, I'm able to rework everything in the introduction and we can focus exclusively on the next chapter, which is on GPU abstractions. Yes, I think that's true. Like NVIDIA RTX 4090 has 16,384 CUDA cores for such computing. Does it have that many? I thought it was 8,000. I thought it was half that. But maybe I misremembered. But you can't do branching effective you can't effectively do branching on the GPU. As I understand, GPU lacks flexibility. That is true. There's certain applications that GPUs are not good at. Anything that's highly iterative, GPUs are not good at this. Anything that deals with like traversal, tree traversal, or graph traversal, or things like this, not very good at that. Anything with branching, GPU's not very good at this. That's why, like, for ray tracing, for a long time when people were doing recursive ray tracing, which basically means when your ray of light hits an object, it splits off into a reflected part, a transmitted part, and then maybe a coloring part. That type of ray tracing was not done historically on the GPU because that recursive nature was actually directly not, like, it was not enabled. You could not do recursion very deeply on the GPU. And so that was done on the CPU for a long time, right? And Pixar did most of its early movies, I think, on the CPU when it went to full ray tracing for Monsters University. I think. I might be making that up. I actually don't know their exact rendering pipeline, but at that time, I think CPUs were preferred for that type of ray tracing, I think. Long story short, there are certainly applications that are not good on the GPU, and though you can get a fantastic benefit, and even in this next chapter, I talk about a specific application that you get a really good benefit from. There are some situations where it just makes more sense to use a parallel CPU. I've only ever studied theoretical physics and classical mechanics. I want to go into computer simulations for mechanical systems later on. Would be cool. Hey, this is actually probably a pretty good project, or a pretty good book to read. My hope is that you are one of, like, that specific audience, you know, someone who has a basic general understanding of programming, kind of wants to get into it more, is like, that's what this book is for. Like, people who have some general understanding, they want to go deeper, they don't know how to go deeper, and I can explain that, right? That's what this is, you know. My wife, for example, is a theoretical physicist as well, and in a way, I would like for her to read it and to tell me what she thinks, because I think that her knowledge about, like, where she is right now is kind of perfect for this book. It's like, you know, just enough that you have your feet wet, but not so much that you understand the nuances, and that's the point. And, like, you know, I might be tempted to have someone who is a theoretical physicist or something like that to be put down as a prominent reviewer for the work, because it shows that the book was not just reviewed by people who know Julia, not just reviewed by people who know, you know, GPUs. It was also reviewed by people who don't know GPUs, and they also gave it the thumbs up. Like, this is exactly the type of people I want reading the book and to give me feedback. Yes, I think that's it. So I think that's it for today. Let me go ahead and check to see what's going on over here. Okay, so we talked about a bunch of different things today, so let me just go ahead and recap what we did. So we started a stream, a little bit of rambling. Look, you can't have a Leos Lab stream without rambling. That is just the nature of these types of streams. I'm so sorry. I do my best not to ramble, but it's impossible not to. I've learned that over years of streaming. I wish I was better. But long story short, we did a little bit of rambling, talking about kind of why I haven't been streaming for the past month or so, and a lot of it is because I've been writing this book, but I've also been writing other stuff as well. Not only this book, I've been finishing up MIT work. I've been writing a couple papers. I've been writing this book. I have another book I'm writing. I have so much stuff going on. I've been trying to do my best to stream, and I'm trying to decide how I want to proceed with the streams in the future. I'm not sure if I should continue doing streams like this, where I just do the writing on stream and we kind of go through it like that, or if I should wait until a chapter is fully done and then read through the chapter like we did here. I don't know. I'm not sure how I want to do this. But certainly by next stream, my hope is that I have this chapter fully finished and we don't have to reread through it. And then I have the next chapter for like all the ways to GPU. I have this one ready to go as well, so we can review that one. That's my hope. There's some little stuff here that I know I'm going to have to fix, and I'm going to try to do that either tomorrow or over the weekend. But I do believe I can get that done by next stream, which again, will either be tomorrow or on Monday. I'm not entirely sure. I think that's it for now. So thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. Again, I do appreciate you being here. And let me know what you think, either in the chat here, or maybe in the comment section of the YouTube video, or on Discord or whatever. I'm still trying to find, I understand that writing a book is not necessarily the most, like, the best thing, like the thing that most people are interested in. And it'd be nice if we could just do hard-hitting research. I'd love that. But I also acknowledge people don't like doing hard-hitting research. So I don't really know. I don't really know what the best thing to do is here. But I'm very interested in feedback. Could you do an interesting project in the book that would be a spectrum analyzer? It seems perfect for the GPU. So I am intending to do stuff with an FFT, which would allow you to do spectral analysis. My plan was to do a convolution with FFTs, because I feel like the convolutional theorem used for FFTs, used so that you can do a convolution with FFTs, is actually an easier formulation than other types of convolutional methods. And so I was intending to do that because I think it's straightforward. But I'm not sure if we want to do full spectral analysis. I think there is something we can do there. I need to think about what specifically that would look like. But that's a really good idea, and I need to keep that in the back of my head. Good, and also keep in mind on Discord, we have a specific channel for the GPU Handbook. So if you have things you want to talk about, just go to the GPU Handbook channel and talk about it, right? And again, to let everyone know, we have a research topics forum. If there's a research topic you want to cover and you think this community could help, go ahead and create it like a post on the forum, and we'll talk about that. And we could eventually work that into something that we do on stream and all that kind of stuff. Okay, I think that's all the updates. Thank you guys so much for coming in. Again, have a great day. See you next time. Bye, guys.